February 1998. A NORAD radar operator watches his screen go silent, not from malfunction, from impossibility. 41,000 feet above the Fox Basin, something metallic holds position against 70-knot winds without moving an inch. Every diagnostic runs green. Every backup system confirms this is real. The object then does something no aircraft on Earth can do. It drifts laterally for 18 minutes while maintaining altitude within 50 feet. No thrust signature, no heat bloom. Just movement. 3 separate command centers track it simultaneously. When the Air Force classified the file, they stamped one word across the cover: unexplained. Tonight, that file opens. And what you're about to see in the next 3 hours will rewrite everything you thought you knew about our monitored skies. In this 4th episode, we shift our focus to those curious behavioral anomalies. Each event was meticulously logged, verified against environmental data, and compared across multiple radar sites, yet none aligned with aircraft performance limits or typical atmospheric dynamics. Some tracks persisted for merely a minute, whereas others continued long enough to engage more than one command center. This production operates independently and bears no affiliation with NORAD or any governmental entity. All material is sourced from publicly released documents and historical surveillance records. Welcome to the NORAD Files, Episode 4, The Fox Basin Lateral Drift NUNOT, 1998, Archival Reference. NORAD North Warning System. Surveillance Record 9802 DLK. In February 1998, Dior Lakes, situated on the central plateau of Baffin Island, executed its routine long-range surveillance of the Fox Basin region, utilizing one of the mid-latitude North Warning System radars, intricately linked to the NORAD air defense grid. Radar conditions on that wintry night were typical for late winter, characterized by solid temperature stratification, minimal clutter levels, and moderate crosswinds flowing eastward across the basin at approximately 70 knots. Telecommunications established with North Bay, CFS Clyde River, and the Alaska NORAD region operated without issues. Sweep integrity, antenna rotation, and diagnostic checks all remained within nominal values during the first half of the shift. Nothing indicated that the monitoring session would deviate from its usual routine. The irregularity emerged at 21 hours and 12 minutes local time amid a standard sweep cycle. A compact, high-confidence primary return appeared prominently in the central sector of the basin, positioned at an approximate altitude of 41,000 feet. The amplitude exhibited characteristics consistent with a metallic or otherwise coherent reflective surface. Operators stationed at Dior Lakes promptly executed the first requisite action: confirming system health. Transmitter output, timing circuits, receiver sensitivity, and signal processing thresholds were assessed in rapid sequence. All indicators confirmed normal operation. There was no sign of internal noise, transient power fluctuations, or sweep artifacts. The object's altitude remained remarkably stable across successive sweeps, with vertical variation measured at less than 50 feet. Such stability is unusual for any high-altitude aircraft contending with the documented crosswinds in the region. The lateral displacement, however, was the element that warranted escalation under NORAD procedural rules. Instead of tracking along a forward trajectory consistent with flight paths or drifting with the wind, the return slid sideways across the basin. This lateral movement stood in stark contrast to the prevailing wind conditions of that evening. The velocity, derived from shifts in range and azimuth, indicated several hundred knots of cross-track motion. The second procedural step necessitated correlation attempts. Dior Lakes reached out to CFS Clyde River, requesting an examination of the corresponding sector from their strategic position. Operators at Clyde River successfully identified the same return within 2 sweeps. Its altitude backed the estimate from Dior Lakes, and the lateral vector corresponded as well. Both stations verified stable calibration throughout the detection period. With 2 independent radars confirming the presence of a non-operational object, Dior Lakes commenced a formal uncorrelated track notification to the Canadian NORAD region. The track received a provisional designation, UT-98FB01. NORAD's Regional Coordination Center requested high-resolution sweep captures and directed both stations to maintain uninterrupted observation. They then proceeded to the subsequent step in the protocol, airspace reconciliation. Civil aviation registries for northern Quebec and Baffin Island revealed no aircraft operating at that altitude and confirmed an absence of west-to-east ferry routes, alongside a lack of special authorizations for military flights. There were also no foreign surveillance missions slated over the Fox Basin region. Transport Canada reported no high-altitude civilian aircraft in operation. The military registry listed no patrol flights, no search and rescue missions, and no experimental activities taking place in the vicinity. As the object continued its unorthodox lateral progression, the operators conducted an in-depth analysis of environmental factors. Meteorological diagnostics revealed no inversion layer capable of generating ducted reflections. Upper air soundings earlier in the day failed to indicate temperature gradients robust enough to create false lateral motion effects. Ice drift radar reflections typically display fluctuations that result in irregular phase shifts and amplitude distortions. However, this return exhibited none of those behaviors. Its brightness maintained consistency throughout, while its outline retained the same shape with each sweep. Phase coherence proved exceptionally high for a target that was moving against winds of that magnitude. At 21 hours and 17 minutes, NORAD's Central Review Team sought sensor data from remote environmental monitoring stations. All measurements affirmed stable atmospheric conditions existed. There were no auroral arcs, no polar ionospheric scatter, no magnetic irregularities, and no storm systems within 400 kilometers. Operators endeavored to reconcile the object's behavior with known patterns of anomalous propagation, yet the lateral drift at altitude could not be replicated by any combination of environmental variables recorded that night. Darrer Lakes maintained its tracking as the return traversed the central expanse of the Fox Basin. Across each observation, the lateral motion remained flawlessly linear. There were no oscillations present, no drops in altitude, and no inconsistencies in the track width. The velocity estimate remained stable. Objects such as drifting debris, balloons, or formations of ice crystals would have demonstrated irregular accelerations or altercations in shape across the radar beam. The object functioned instead like a controlled aerial entity, despite the motion failing to conform to conventional aircraft aerodynamics or expected wind influences. Operators at Clyde River sent their fractional azimuth measurements to analysts at NORAD. These figures corresponded precisely with those from Darrer Lakes, remaining well within the acceptable margin of error. A two-station lock boasting that level of precision significantly diminished the likelihood of any environmental origin. According to NORAD protocols, coherence between two stations is adequate to elevate an event from provisional uncorrelated tracking to priority uncorrelated tracking. This necessitates real-time evaluation by the command center located in North Bay. Consequently, inquiries were dispatched to both U.S. and Canadian maritime authorities to eliminate the possibility of reflections caused by vessels. No marine activity was logged in proximity to the basin during that night. Even in the hypothetical scenario where a ship had been present, the return's altitude and lateral movement were incongruent with reflections originating from the surface. Moreover, the radar cross-section exhibited a pulse-consistent hard return, differing markedly from the distorted multipath signature typically associated with reflections off the ocean's surface. By 2121, the object had traversed a considerable segment of the basin while sustaining altitude within 50 feet and velocity within narrow tolerances. The object offered no transponder response when queried by secondary radar, nor did it respond to attempted Mode 3A and Mode C interrogations as standard protocol dictates. Both attempts proved negative. No IFFF signal was ever detected. The absence of transponder data firmly designated the return into the category of non-operative aerial activity. Approaching 2123, The track neared the western opening of the basin, where sea ice gave way to broader passages. Operators maintained keen vigilance on amplitude, searching for any indicators of weakening or scattering in line with an object descending beneath the radar horizon. In contrast, the return remained unclouded before ceasing abruptly without any transition. One sweep depicted the object. The next revealed only empty space. There was neither an outbound vector nor any fading or distortion. Clyde River confirmed the simultaneous cessation. NORAD protocol mandated immediate post-termination sweeps to probe for residual scatter or secondary signatures, but none were discovered. Searches were broadened across nearby sectors, considering the possibility that the object had veered off course swiftly enough to escape the primary tracking corridor. Yet again, no return surfaced. All systems continued to operate normally, removing the prospect of equipment failures. North Bay proceeded with the standard post-incident workflow. Dior Lakes transmitted comprehensive diagnostic logs from the detection window, revealing no transmitter variations, no antenna rotation anomalies, and no faults with the receivers. Diagnostics from Clyde River presented an identical clean operational profile. Atmospheric logs indicated normal winter stratification, devoid of thermal anomalies. Civil aviation affirmed once again that no flights were in the vicinity, while military operations attested to the absence of aircraft or missile activity. Orbital tracking facilities identified no satellites capable of generating low-altitude glints congruent with the motion recorded. Radar analysts scrutinized the lateral drift vector. No aircraft in 1998 could sustain a consistently level altitude while moving at hundreds of knots horizontally against 70-knot crosswinds, lacking visible aerodynamic compensation within the trajectory. The motion did not conform to the aerodynamic capabilities of any fixed-wing or rotary-wing craft. It also did not align with any known unmanned aerial vehicles or reconnaissance platforms. Although the object's radar cross-section was not large, it maintained a stable and coherent presence, hinting at a solid surface. North Bay finalized its assessment 3 days later, categorizing the incident as an unresolved non-operative return with confirmed two-station corroboration. The stable altitude, lateral displacement inconsistent with either atmospheric or aerodynamic behavior, and the abrupt cessation of the return were duly noted. Adjacent surveillance networks yielded no correlated data. The Fox Basin remained isolated to the sequence of sweeps captured that night, showing no identifiable follow-through. No further detections emerged during that week, nor were there any associated sightings reported by air or marine traffic. Dior Lakes reverted to its standard operational procedures, its radar resuming its quest for regular aircraft and known background patterns. The February event lingered as a unique anomaly within that year's surveillance records. In the concluding lines of the archival record, the description preserved the core conclusion devoid of conjecture. The origin, motion, and disappearance of the object could not be linked to any recognized source, and was thus documented in the surveillance file accordingly. The reference to the Montana Ridge intercept return was made, identifying Montana, USA. 1883. Archival reference, NOR Continental Surveillance Record, 8304, Mr. April, 1883. The northern plains of Montana were serene that night, with nothing out of the ordinary navigating through the air corridors connecting the western missile fields to the southern training ranges. The long-range radar site tasked with monitoring the region operated at the same steady cadence observed on most weeknights. The personnel surveyed the standard mix of training flights, civil aviation paths, and the fading signals of commercial jets descending toward destinations such as Seattle, Spokane, and Billings. The radar systems employed during that period stood as integral components of the NORAD command structure, executing stable, predictable sweeps that yielded clear returns, unless variables such as weather or maintenance introduced distortions. On this particular night, elements that could have disrupted operations were notably absent. Diagnostics reflected normal status, power output remained unwavering, and the timing of the sweeps adhered perfectly to its anticipated values. Shortly after 9 o'clock that evening, a B-52 from an Air Force training wing commenced a scheduled low-intensity mission traversing northern Montana. The radar operators confirmed the aircraft's transponder code, track, and altitude as they initiated flight monitoring. Ground controllers were afforded complete visibility of the bomber, which maintained a steady altitude of approximately 33,000 feet. The meteorological conditions were favorable, with clear skies prevailing. Moderate upper winds did not introduce any challenges for long-range detection. The radar operators settled into their established routine of tracking the B-52 along its preordained path. Then, an unexpected radar return materialized. This anomalous signal emerged alongside the B-52 track during a sweep that revealed no irregularities. The operators swiftly identified a bright primary reflection situated just a few nautical miles from the bomber. Intriguingly, this return bore no transponder signature. Its radar cross-section emerged distinctly, emanating a clean, steady signal strong enough to be recognized immediately as possessing a definitive physical structure. Initially, the operators suspected it might be a trailing aircraft yet to be logged in civil aviation channels. However, its altitude matched that of the B-52 precisely, and no such flight had been authenticated or cleared. Within 2 sweep cycles, it became evident that this new return was closely shadowing the bomber, prompting operators to validate the radar system's performance. The transmitter output was scrutinized, and receiver sensitivity values were assessed. Pulse timing received affirmation, with no signs pointing to a malfunction within the system. Sweep tracking sustained stability, and the radar's integrity checks confirmed flawless operational status. Throughout each subsequent sweep, the primary return displayed a consistent shape, uncharacteristic of clutter or multi-path reflections. Once the system's health was reaffirmed, operators forwarded the initial uncorrelated track report to the NORAD Regional Center. The return lacked identification, a transponder, or any correlation with aviation logs, thus receiving provisional classification as an uncorrelated radar return. In accordance with protocol, operators were directed to maintain continuous sweep recordings. NORAD mandated that any return in close proximity to a military aircraft required the radar site to initiate high-detail track capture, allowing for meticulous monitoring of potential acceleration, deceleration, or altitude fluctuations. Ground communication channels linked directly with the B-52 crew, who validated their position, altitude, and flight conditions. The pilots reported clear visuals. Noting the absence of any anomalies, their onboard instruments displayed only their radar signatures, along with familiar terrain features. Remarkably, they observed no sighting of any aircraft alongside them. Following NORAD protocol, a secondary radar installation was contacted. The Dickinson radar site in North Dakota possessed overlapping coverage for the operational area at that altitude. However, its angle to the target differed. Dickinson was tasked with scanning the coordinates of the unidentified return. Within the next sweep cycle, confirmation arrived from the station. The altitude was identical to that of the bomber, and the target's speed matched with exact precision. Both stations recorded stable amplitudes without interference due to environmental factors or propagation anomalies. Now, 2 independent systems were tracking the same object in synchronized pace with a United States military aircraft. The previously uncorrelated track was elevated to a higher operational priority. The regional NORAD Center commenced a thorough cross-check against civil aviation databases. No accounts of aircraft had been cleared for flight in that corridor, nor had any transponder codes been issued for the specific altitude and location concerned. Air traffic control centers reported no missing or delayed flights, and there were no foreign aircraft authorized in the vicinity. The civil aviation records yielded no discrepancies. Subsequently, the regional command delved into military flight patterns. Strategic Air Command had not allocated additional aircraft within that sector. That night, NORAD's classified corridors designated for strategic operations remained silent. No air defense exercises were currently in progress in the northern Montana region. There were no active test vehicles or high-speed experimental aircraft deployed. The absence of sanctioned military flights heightened the significance of the occurrence. The radar operators continued to monitor the return. For 6 continuous minutes, the unidentified object maintained a perfect pacing position relative to the bomber. It neither advanced nor lagged behind. The object sustained its altitude without any vertical fluctuations. Signs of turbulence were non-existent. The radar cross-section exhibited no variation, which strayed from typical behavior for aircraft in loose formation. Minor wind variations at that elevation typically cause minute positional adjustments when two aircraft navigate in proximity. None of these effects were observed. The unidentified return moved as if locked in step with the bomber's velocity and trajectory. NORAD analysts diligently monitored the radar feed in real time. Their primary objective was to rule out known causes. Weather balloons did not align with the recorded altitude or speed, while atmospheric distortions would fail to produce a coherent return fixed adjacent to a swiftly moving target. Radar reflections originating from the ground or from elevated atmospheric layers would manifest irregularly, intermittently, or shift concerning the lead aircraft's heading. None of these scenarios matched the observed pattern recorded by operators. At 2:16 local time, the unidentified return altered its behavior. Operators at both radar sites noted that the return initiated a climbing maneuver. The ascent presented itself as vertical concerning the ground track, devoid of any horizontal deviation. Radar readings indicated an altitude shift of several thousand feet within a single sweep interval. In the subsequent sweep, a further significant jump in elevation was recorded. The climb progressed at speeds surpassing any aircraft currently in operation by the United States within that altitude band and exceeded expectations for foreign technologies as well. The steepness and abruptness of the ascent defied the principles of aerodynamics. Meanwhile, the B-52 maintained its course, tracing its usual route as the unidentified return continued its vertical ascent overhead. The data capturing routines at NORAD transitioned to a heightened state of detail. Altitude estimations were recalibrated, and the velocity measurements were meticulously checked for any potential signal errors. Remarkably, no errors were detected. The ascent rate was far beyond the capabilities of known aircraft by a considerable margin. The crew of the B-52 reported no sign of sonic booms or any visible phenomena above them. The vast night sky appeared utterly unmarked to their gaze. In the next radar sweep, the return flickered and gradually faded. There was no observable decrease in intensity. It did not shift toward the radar's outer edges. Instead, it simply diminished until it sank below the threshold of detection. The Dickinson radar corroborated this disappearance, with both monitoring stations affirming the loss of signal. In accordance with NORAD's established protocols, operators initiated an extensive post-event observational window, widening both azimuth and elevation parameters in the search. Yet, no reappearance of the unidentified return ensued. There were no discernible trailing echoes or residual scatter. The region remained strikingly clear. The regional NORAD center commenced the post-event protocol, meticulously reviewing both civil and military logs. No communications loss by any aircraft was reported, and no emergency beacons were activated. Additionally, there were no flight plans that correlated with the unusual behavior of the object. Ballistic missile trajectories were systematically ruled out in collaboration with the United States Strategic Command. There were no falling re-entry vehicles over the vicinity. No radar from the Space Surveillance Network identified any object operating at that elevation. Meteorological experts verified that no inversion layers could have created misleading returns. Furthermore, there were no zones of significant wind shear present that might distort radar energy. Solar activity was not a factor interfering with long-range detection capabilities. The atmospheric conditions presented were insufficient to explain the observed pacing behavior or the pronounced vertical climb. The B-52 crew submitted a supplemental report, confirming the absence of visually discernible anomalies and stating that their instruments recorded no unusual readings either. Radar technicians from both stations meticulously reviewed their system logs, confirming that transmitter power, timing mechanisms, and calibration were all consistent with operational standards. No spike events, phase errors, or oscillation complications were found, and every system functioned as expected. Analysts at NORAD compiled the radar imagery into a comprehensive track file. The featured behaviors, pacing, altitude congruence, velocity consistency, and vertical ascent, were all cataloged as pivotal facets. However, no explanation aligned with the data collected. The case was subsequently archived under its unique reference number, noting that the return had maintained a station next to a bomber for several minutes, executed a rapid and vertical ascent inconsistent with known aircraft, and vanished without any correlation to other detection networks. This incident remained one of the most extensively documented instances of an uncorrelated return from the early 1980s. Shifting focus to the Nunivak Channel in western Alaska in the year 2001, archival reference indicates NOR, Alaska. On that quiet night, the western coast of Alaska presented a clear boundary between the Bering Sea and the air corridors leading inland into the Alaskan NORAD region. Weather reports throughout the Bering Sea Channel depicted stable atmospheric pressure and untainted upper-level winds. No thermal inversions were detected, and the sea surface lay calm beneath a light westerly breeze. At the radar station tasked with overseeing the western sector near Nunivak Island, operators conducted routine surveillance of the North Pacific entry lane. Earlier that evening, the equipment had completed its diagnostics, confirming that all operational parameters remained nominal. Sweep-to-sweep integrity assessments resulted in perfect timing, with no detectable drift in antenna rotation. The night commenced as simply another predictable watch along the western edge of North American airspace. At 21:42 local time, a solitary return appeared at mid-altitude, positioned over a corridor west of Nunivak Island. The radar displayed this return with clarity, devoid of scatter or trailing noise. The strength of the radar cross-section qualified the return as a reflective aerial object rather than as sea clutter or multipath interference. The altitude estimate placed this return within a region typically traversed by long-range aircraft entering Alaskan airspace. For the initial several sweeps, the object maintained a consistent easterly-northeasterly course, with velocity readings falling within the lower spectrum of conventional aircraft performance. However, this return was notable for lacking any transponder signal. The operators recorded the detection and initiated standard verification steps pertaining to the uncorrelated track. The first procedural measure demanded an assessment of system integrity. Transmitter output remained within designated power levels, while the receiver noise floor exhibited no elevated fluctuations. Phase stability was consistent, and the timing circuits governing range gate positioning underwent both manual and electronic verification. Operators confirmed that no anomalies existed within the pulse repetition frequency. Indications confirmed a standard operating environment free from any fault that could generate a false target. The return persisted as coherent and stable, displaying no fluctuations in amplitude that would suggest inconsistent reflection. At 21:43, 1 minute after the initial detection, the return experienced a transformation that immediately seized operator focus. The object segmented during a single sweep. Instead of one compact return, the radar portrayed two distinct returns, now spaced roughly 6 nautical miles apart while maintaining the same altitude and matching velocity. There was no transitional blur observed between the two. On one antenna rotation, the radar depicted a singular object. On the next, it illustrated two separate entities. The operators visually confirmed the absence of smearing and phase distortion effects. Both newly detected returns appeared distinctly formed and stable. They exhibited equal amplitude and maintained an identical heading. The first internal review process entailed checking for potential side lobe interference. Such interference generally results in weaker ghost images, characterized by differing amplitude from the primary return. However, these two returns displayed identical signal strength, their radar cross-section values aligning perfectly with those of the original object. The operators scrutinized the antenna pattern logs to verify the effectiveness of side lobe suppression. Those logs confirmed the equipment functioned at nominal performance standards, effectively ruling out the likelihood of false side lobe reflections. In accordance with NORAD procedures, any track exhibiting non-standard behavior necessitates a prompt correlation attempt with the region's secondary radar systems. Thus, the operators relayed the detection to the Alaskan NORAD Regional Command Center, located in Anchorage. That command center subsequently dispatched a request to the Bethel Long-Range Radar Site to inspect the corresponding airspace. The Bethel site corroborated the detection of two objects along the same azimuth line and at an equivalent altitude. Their readings mirrored the spacing noted at the Nunivak station. This two-station verification firmly established that the dual returns were authentic and not locally generated artifacts. The next step in the established procedure involved cross-referencing civilian air traffic systems. The Anchorage Center provided detailed flight plan information alongside transponder logs, revealing no scheduled aircraft in the vicinity of that portion of the Western Corridor. No flights were routed along the trajectory of the dual returns, nor were there military training missions reported in the vicinity or any naval aircraft transit notifications. Furthermore, no foreign overflight permissions had been authorized for that sector on that date. The absence of any authorized traffic elevated the situation to an uncorrelated multi-return event. By 2,146 hours, both returns persisted on a parallel course, their separation remaining constant across radar sweeps. There was a notable lack of compression or drift in their spacing, a detail that operators marked as unusual given the stability of their formation. Conventional aircraft cannot sustain such consistent spacing without coordinated control inputs or visual formation flying. Yet, the FAA confirmed that no aircraft were within coverage. Radar technicians began investigating potential ducting phenomena, which can occasionally create false echoes over water. Ducting conditions require robust temperature inversion layers, typically resulting in stretched or distorted returns. However, that night's atmospheric profile did not support the formation of inversion layers. Meteorological data from the Bering Sea corridor indicated an even temperature gradient devoid of any sharp boundary capable of trapping radar energy. With ducting ruled out, by 2,148 hours, NORAD requested the immediate transfer of high-resolution sweep data to the Regional Analysis Cell. The radar station initiated the capture of every sweep with maximum data retention, ensuring that amplitude, phase, range, azimuth, and altitude measurements were preserved in real time. These measurements would subsequently be compared with data from the Bethel radar and any available satellite sources. By 2,149 hours, NORAD established contact with the Space-Based Infrared System and the DSP Satellite Monitoring Network to investigate for any thermal activity within the region. The DSP sensors reported no thermal signatures indicative of powered aircraft or re-entry vehicles. The dual objects demonstrated no detectable energy output from orbit. This absence of thermal emission suggested that the objects were either exceptionally cold or operating without conventional modes of propulsion. Meanwhile, the returns at the radar station maintained an exemplary state of stability. The amplitude of both signals exhibited minimal variance, while their cross-section remained consistent. Altitude readings maintained steadiness across all sweeps. Their velocity remained unchanged, with the interval between them exact. Operators noted this was inconsistent with debris fields, as debris fragments typically exhibit divergent movement and variable radar returns. By 2,151 hours, the dual objects approached a point where the eastern return began to diminish in amplitude. The weakening occurred gradually over two sweeps, and on the subsequent sweep following this drop, the eastern return vanished entirely. The western object persisted. Operators registered this transition and investigated the potential for the second return to have fallen below the detection altitude. However, this possibility was dismissed based on altitude logs indicating no descent. The surviving object continued its trajectory northeastward across the channel. NORAD directed the radar station to maintain primary tracking, simultaneously forwarding the positional data to the coordination center. Once more, the Anchorage Center confirmed the absence of any correlated aircraft in the area. The Bethel radar further continued to track the remaining return for an additional minute before it, too, began to fade. By 2,153 hours, the western return disappeared. Its termination was noted to occur without any signs of acceleration or descent. In one sweep, the signal registered powerfully. In the next sweep, the sector revealed nothing. This type of termination is characteristic of non-kinematic disappearance, a classification used by NORAD for objects that exit radar coverage without any observable transitional movement. Following this event, NORAD swiftly initiated the post-event process. All logs from the Nunavak station were preserved within the event package. The region then requested comprehensive diagnostics from the radar system. Both transmitter logs and receiver stability data indicated no system malfunctions. Intermediate frequency stages remained stable, with no inconsistencies in antenna speeds. Timing circuits exhibited correct operation throughout. The equipment had functioned flawlessly during the detection window. Meteorological data underwent meticulous analysis, accounting for upper-level temperatures, pressure layers, humidity content, and wind shear measurements. All atmospheric conditions remained stable during the entirety of the event. No inversion capable of generating ghost returns was identified. There was no turbulent interface to produce splitting patterns. The prevailing weather conditions failed to explain either the split or the dual parallel behavior observed. Satellite cross-checks executed through the Joint Space Operations Center confirmed that no orbital debris could be responsible for the phenomena. Debris cannot separate into two equally stable elements at identical altitudes. Furthermore, debris does not possess the capacity to traverse at a controlled low orbital velocity. Throughout this period, no satellite maneuvers were recorded in the relevant region. The absence of thermal signatures in the DSP eliminated the possibility of re-entry materials being involved. A thorough review of radar history revealed that merely a handful of incidents within the Alaskan NORAD sector had noted multi-return formations with similar characteristics. However, none of these involved abrupt splitting behavior, resulting in two coherent returns maintaining perfect spacing. Analysts from the Alaskan NORAD region determined that the observed objects exhibited behaviors that were inconsistent with known aircraft debris or environmental reflections. The event was classified as a multi-return anomaly, devoid of any identified origin. Upon the cessation of both objects, a return to background classification was enacted. The region remained under standard surveillance for the subsequent week, during which no further anomalies were detected along the same corridor. This event stood out as singular to that particular night. The case was subsequently recorded in the NORAD Alaska surveillance log for July 2001 as a thoroughly verified multi-return event, supported by dual station confirmations and a complete lack of environmental or operational correlations. Turning our gaze back to the Mackenzie River incident in the Northwest Territories in 1976, we find archival reference in the NORAD Northern Surveillance Log 76 Zoho 4 MRH, dated August 1976. During that late summer evening, the atmospheric conditions over the Northwest Territories demonstrated an unusual stability. Typically, the Mackenzie Valley is known to generate complex wind patterns, a result of warmer southern air colliding with colder currents descending from the Arctic. Yet, on this particular night, the vertical temperature profile indicated only benign stratification. Ground winds were placid, upper-level winds remained moderate, and the pressure gradient throughout the valley stood steady. Reports from Inuvik, alongside the smaller inland radar sites, noted no thermal inversions or anomalous propagation layers prior to the onset of the shift. These conditions were ideally suited for high-altitude surveillance, leading operators to anticipate an uneventful operational cycle. However, at 21:48 local time, the radar station situated south of Inuvik detected a return that did not conform to any anticipated traffic. The trace, appearing at roughly 28,000 feet above the central expanse of the Mackenzie River corridor, exhibited a tightly coherent outline with no fluctuation in amplitude throughout the sweeps. Following standard procedure, the operator promptly initiated a system self-diagnostic. The transmitter power remained within nominal tolerances, receiver sensitivity was stable, and the timing circuits displayed no cyclical slippage. The rotation speed of the antenna was accurate, and sweep persistence behaved as expected. There was no indication of equipment malfunction. The subsequent step mandated correlation with atmospheric data. The station retrieved upper air soundings from the nearest weather balloon launch alongside updated satellite-derived moisture profiles. Moisture levels aloft were determined to be too low to establish any reflectivity strong enough to simulate a stationary aircraft. No localized cloud formations were present. Nor was there any ducting layer capable of trapping radar energy. The environmental readings provided no means for ground scatter or mirage returns at that altitude, leading to the classification of the return on the scope as a genuine primary target pending confirmation. Adhering to standard NORAD protocols, immediate cross-station verification was required. Inuvic's long-range radar was directed to examine the corresponding azimuth and elevation slice. Their scope registered the same return within moments. The altitude estimate was almost precisely aligned, as the cross-section matched in both strength and coherence. Inuvic also confirmed stable internal diagnostics. With two stations substantiating the presence of a stationary object at altitude, the contact was provisionally designated as an uncorrelated stationary return and forwarded to the Canadian NORAD region for further assessment. The next procedural phase involved a search for correlated aircraft. Database inquiries into civilian air traffic reflected no flights approved to operate at altitudes near the Mackenzie Corridor during that time frame. The airways in that region remained underutilized at night, and no scheduled transports were found to operate near 28,000 feet. The military flight registry did not reflect any northern patrols or training operations either. No charter flights were recorded, and no general aviation aircraft were anticipated in that environment due to the weather conditions, terrain challenges, and a lack of navigational coverage that rendered nighttime operations exceptionally rare. This absence of correlated traffic consequently elevated the return's priority status. Throughout subsequent sweep cycles, the object remained unchanged in position. It did not drift with the upper-level winds, which were reported at approximately 45 knots from the west. At that altitude, any object lacking active control would almost invariably shift. Even minor balloons exhibit notable displacement under such wind conditions. In contrast, the object displayed on the radar scope maintained its precise location, unyielding since its initial appearance. Regional Command at NORAD instructed both stations to commence high-fidelity capture with detailed recordings of sweep data, amplitude values, signal-to-noise ratios, and phase stability readings executed with greater granularity. The radar return from the object displayed remarkable consistency. The amplitude varied less than half a decibel across sweeps. The outline proved compact, and no signs of rotation, scintillation, or irregular reflection were present. The characteristics aligned more with a hard structured surface as opposed to particulate matter or a transient atmospheric target. By 2153, the Canadian NORAD region commenced pulling data from additional sources for deeper analysis. Meteorological Command confirmed the absence of weather anomalies over the river valley. Satellite imagery unveiled clear atmospheric conditions devoid of cloud cover sufficiently dense to disrupt radar functionality. With auroral activity registering low and solar wind readings remaining mild, geomagnetic indices offered no indication of ionospheric refraction occurring at that moment. Analysts validated that no known natural phenomena could generate a coherent stationary return at the altitude reported under the aforementioned conditions. Inuvic radar meticulously examined its clutter map, juxtaposing the target signal with previously cataloged ground features, terrain reflections, and historical instances of multipath interference. None matched the radar's findings. The geometry associated with the detection rendered ground reflection improbable at the noted elevation. Beneath the object lay an irregular landscape of forest and riverbank, conditions inadequate to produce the sharp return evident on the display. Eliminating environmental and equipment factors paved the way for the next phase of NORAD protocol, which entailed cross-referencing with national defense resources. Canada's Department of National Defense reported no ongoing operations in that vicinity, while the United States Air Force liaison for the Alaskan NORAD region noted that no strategic aircraft, reconnaissance vehicles, or test platforms were active anywhere near the Mackenzie Valley. There were no indications of missile tests, suborbital experiments, or classified movements capable of situating an object at 28,000 feet while exhibiting stationary characteristics. By 2157, the object had maintained its position for nearly 10 minutes. Both radar stations persisted in tracking it without any fluctuation. The stability of this return captivated the attention of analysts. Typically, objects hovering at altitude are subject to some degree of drift or oscillation, even when equipped with advanced propulsion systems. Yet this return displayed none of those qualities. The associated radar cross-section stayed remarkably consistent, sweep after sweep, indicating that if the object rotated, tumbled, or adjusted its orientation, such motions failed to produce any detectable change in its reflective characteristics. At 2159, NORAD Command instructed the stations to investigate the object's vertical movements. Operators initiated the measurement of any minuscule alterations in elevation, analyzing micro-variations in pulse timing and the angle of arrival. The altitude remained static within the system's narrow margin of error. The return neither ascended nor descended, steadfastly locked at approximately 28,000 feet. A further step of verification entailed contacting military and civilian communication networks to gather reports of unusual lights, aerial disruptions, or interference. No pilots logged any such reports, nor did ground observers from regional communities take note of any anomalies. Marine vessels navigating the Western Territories affirmed the absence of irregularities in their observations. Nothing provided visual corroboration for the radar detection. At 2,000 hours, the target vanished. Its disappearance was instant. One radar sweep displayed the complete stable return, while the subsequent sweep revealed nothing but empty sky. The cutoff occurred without fading, fragmentation, or any gradual decline in amplitude. Such instantaneous termination ranks among the most anomalous signatures detected through early warning surveillance, as virtually no natural or technological phenomena yield such a sudden cessation at altitude. Protocols dictated by NORAD necessitated immediate post-termination monitoring. Consequently, both radar stations sustained scanning of the region for several minutes afterward. No secondary returns emerged, and no trailing signals or residual scatter persisted. The termination proved absolute. This event progressed into the formal review cycle, with diagnostic logs for both radar stations undergoing sequential analysis. No anomalies in the transmitters were reported. Power stability was maintained throughout the event window, while antenna rotation rates aligned with the documented timestamps. Calibration checks executed immediately following the event indicated that all systems operated normally. Meteorological specialists examined temperature profiles, pressure gradients, and inversion layers relevant to that evening. None could explain the return. Atmospheric ducting was dismissed as refraction patterns contradicted the detection. Furthermore, the aurora's scattering was insufficiently intense to generate stable returns. There had been no aircraft, balloons, or experimental test vehicles present at the reported altitude. Satellite cross-checks verified that no orbital debris re-entered the atmosphere during the window of observation. No low Earth orbit vehicles crossed through the angles necessary to create a glint. Infrared surveillance systems detected no temperature signatures correlated with a stationary object. Even a platform maintaining altitude with propulsion would typically produce detectable heat signatures observable by space-based sensors. Nonetheless, no such thermal activity was recorded. Subsequently, analysts turned their attention to historical cases involving stationary returns above 20,000 feet. A scant few fit the duration and stability characteristic of the Mackenzie River event. Most stationary returns within archived logs comprised short-lived clutter or temperature-dependent reflections. None had featured dual station conformations sustained over several minutes with consistent amplitude and altitude. Ultimately, the incident was classified as an uncorrelated stationary return at altitude with no identifiable source. This terminology mirrored the lack of any supporting aircraft, atmospheric, or equipment explanations for the observed phenomenon. The radar logs were preserved, and the occurrence became part of the permanent record of unexplained detections along the northern surveillance corridor. In the concluding page of the archived summary, analysts noted that, had the object possessed known propulsion capabilities, it ought not to have been able to hover with such precision at that altitude without manifesting movement, drift, or thermal output. The data yielded no conclusive answers. It merely confirmed the presence of something stationary, reflective, and uncorrelated above the Mackenzie River on a tranquil night in 1976. The case file was subsequently sealed without any further reports of sightings. In the ensuing days and weeks, no additional returns mirroring its distinctive attributes emerged. The record remained intact, catalogued as just another instance in which NORAD tracked an object with reliable metrics but failed to identify it within any established framework. The case was wrapped up with the customary procedural notation common in many unexplained occurrences. No correlations with known aircraft or recognized atmospheric phenomena had been made. Thus, the event was logged for future reference. Pertaining to the Labrador Shelf, a high-altitude arc within Atlantic Canada, around 1990, under the archival reference of NORAD, Atlantic Surveillance Record 904 LS, recorded in April of 1990. As the long-range radar site responsible for the Labrador Shelf sector settled into its familiar cadence of spring monitoring, operators anticipated the standard flow of cargo routes overlapping with Canadian airspace. Sporadic weather fronts developing above the North Atlantic, and the occasional high-altitude military flight, either departing from or returning to exercises along the coastline. Initial assessments from the early shift suggested that the night would yield no extraordinary developments. System health checks reported normal conditions. The antenna's rotation proceeded smoothly. Atmospheric stability presented itself well within acceptable parameters. With no inversion layers forming over the Labrador Sea, the environment appeared optimal for detection. At around 141 local time, however, the radar scope illuminated with a fresh return nestled near the eastern boundary of its operational coverage. The return manifested distinctly, its amplitude robust enough to register as a coherent high-altitude signature, rather than mere scatter or distant echo. Following altitude extraction, the object was calculated to be at approximately 58,000 feet. This alone was not particularly remarkable. The station sporadically recorded high-altitude military flights or distant satellite reflections that fit within similar altitude profiles. What distinguished this occurrence from the norm was its immediate trajectory. Within the first two sweeps of the radar, the return advanced along a sharply defined curve. This path bent inward toward the Labrador Shelf in a manner that no conventional aircraft could sustain at that elevation. The turn radii at 58,000 feet are governed by the laws of physics, and the curve materializing on the screen breached those restrictions. The operators reiterated their readings, double-checking pulse timing, angle of arrival, and signal gain to ensure accuracy. All parameters cleared. Aligning with NORAD's verification procedures, a re-evaluation of the radar's timing circuit confirmed no drift, while transmitter power remained unwavering. The signal processor, responsible for distinguishing coherent targets from background noise, revealed no anomalies. Had the arc resulted from atmospheric bending, the return would have exhibited fluctuation or smeared across the sweeps. Instead, it retained a crisp outline, deeming system error unlikely. Consequently, the operators reached out to Cape Kiglip, the closest node in the regional surveillance framework, for an immediate assessment of the pertaining sky sector. Upon completing a full antenna rotation, Cape Kiglip echoed their findings, acknowledging the same return, mirroring the same arc at the same altitude. This mutual verification elevated the classification from a potential transient to a confirmed uncorrelated radar track. The first summary packet reached the Atlantic NORAD region. Operators at the central desk in North Bay initiated a meticulous cross-referencing of all pertinent databases, including civil aviation flight plans, scheduled military routes, coastal operations, and any ongoing submarine-launched missile tests. No matches surfaced. There were no high-altitude aircraft sanctioned to traverse through that air corridor, with no missile launches or re-entry bodies anticipated within the region. Environmental monitoring stations, scattered across Labrador and Newfoundland, signaled no noteworthy meteorological disturbances that could elucidate a bending beam or anomalous signal propagation. As the object continued along its arc, the curvature tightened marginally. The motion exhibited a sense of deliberateness and control, distinctly non-erratic. The return's amplitude remained steady, displaying none of the flickering or phase instability associated with natural phenomena. Every sweep reaffirmed the consistency of the structure. A cold, reflective surface likely caused such steadiness. By Euro 146, NORAD's correlation office accessed geosynchronous satellite logs. No known intelligence or reconnaissance asset occupied a position capable of producing a specular reflection from that angle. Scrutiny of low Earth orbit traffic revealed no alignment with the timing or geometry of the event. Had the track originated from a satellite glint, the returns would have likely fluctuated sporadically. Instead, the track behaved as though it were a self-propelled object executing a controlled turn. Adhering to protocol, operators analyzed radar weather data for any indications of ducting that could facilitate distant signals entering the area. No such anomalies appeared. The atmospheric stratification over the Labrador Shelf remained strikingly simple for the month of April, characterized by a uniform temperature profile extending through both the lower and middle atmosphere. This clarity rendered the detection all the more significant. Cape Kiglip corroborated that the return maintained no fluctuations in altitude throughout the sweeps. Even as the object reached the zenith of its arc, its altitude sustained stability, deviating by no more than the radar's inherent margin of error. Aircraft striving to maintain a turn at that elevation inevitably encounter altitude variations during maneuvers. This object did not exhibit such behavior. At ERO 149, the Atlantic NORAD region commanded a high-resolution sweep capture. Both stations proceeded to relay raw, uncompressed radar frames via secure channels directly to Cheyenne Mountain. Analysts there scrutinized amplitude consistency, phase coherence, and angular precision of the data. The findings remained consistent. The track did not arise from multipath reflections, thermal layers, or surface ice movement. It was, as one analyst noted in an annotation, a distinct object tracing a controlled curve at an extraordinary altitude. As the next rotation commenced, Cape Kiglipate observed a marginal uptick in return strength. The radar cross-section of the object briefly surged by approximately 10%. The catalyst for this change remained ambiguous, although the shift was both subtle and tangible. A recalibration assessment confirmed that this spike was not a byproduct of the equipment. Instead, it seemed to signal an authentic shift in the object's reflective characteristics. On the subsequent sweep, the amplitude stabilized, reverting to its earlier intensity. The Maritime Coordination Office at NORAD initiated communication with naval operations active in the vicinity. None of the units reported any missile tests, aerial activity, or debris-related operations. No vessels were utilizing radar systems potent enough to disrupt the detection capabilities. It was clear that nothing from the surface could have orchestrated the arc. Cape Kiglipate then remarked that the curvature was nearing completion. If the arc were to be mathematically extended, it would trajectory toward the northern open waters, extending well beyond the radar perimeter. The object demonstrated precise adherence to the curve, exhibiting neither acceleration nor deceleration, with no lateral drift. For an aircraft navigating at such altitude, this level of precision would necessitate control surfaces beyond any known capabilities. In 1990, at identification 152, the object reached a segment of the arc that placed it nearly perpendicular to the coast of Labrador. The amplitude continued to show strength while the altitude remained stationary. Cape Kiglapate provided assurance of the radar system's flawless health. The operators at the originating radar site confirmed identical consistency in their readings. At 0153, during the forthcoming sweep, the return simply vanished. There was no indication of fading, no downward motion, no scatter. One sweep displayed a coherent, robust, reflective target. The subsequent sweep revealed nothing at all. The termination was instantaneous. NORAD protocol required that both stations persist in monitoring for a minimum of 10 additional sweeps. Yet, no return was observed. The Atlantic sector initiated the second stage protocol, scanning for associated radar anomalies within neighboring districts. No such anomalies were identified. The disappearance was seamless and total. Weather assessments were conducted once more. No temperature fronts had moved into the sector, nor were there unforeseen turbulence formations. The sea's surface remained relatively placid. The environment held nothing capable of masking or absorbing a target of that radar cross-section. At CO27, the overnight review cycle commenced. Analysts juxtaposed the curvature with known aircraft performance limits. None corresponded. The turning radius necessary to create that arc at 58,000 feet surpassed the structural thresholds of every fixed-wing platform cataloged by North American NATO and Warsaw Pact inventories. Ballistic vehicles are incapable of executing a controlled lateral curve at that elevation. Re-entry bodies do not maneuver in continuous arcs, while satellites cannot sustain slow curving paths within the atmosphere. The motion diverged from that of meteors, atmospheric plasma, missiles, or debris. Cape Kiglapate transmitted its complete diagnostic archive. There were no signs of transmitter instability, antenna jitter, or timing anomalies. The radar functioned precisely as expected. Operators documented the smoothness of every sweep along with an absence of intermittent noise patterns. The next phase necessitated a review of the Defense Support Program's satellite logs. No thermal signatures appeared above the Labrador Shelf during the detection timeframe. A controlled arc at 58,000 feet should have emitted trace heat if propelling through combustion. The DSP yielded no results. Data analysts assembled the entire suite of sweep frames and digitally reconstructed the curvature. The arc was geometrically flawless, showing no deviations, corrections, or anomalies. The curvature initiated cleanly, maintained its integrity through the midpoint, and culminated moments before the object disappeared. As the nightly review concluded, the case remained unresolved. The object exhibited controlled flight behavior without displaying any known propulsion signature. Its maneuverability stood in stark contrast to any documented aerospace vehicle, and its radar termination left no residual trace. This incident was recorded in the year's uncorrelated high-altitude anomaly files, accompanied by complete sweep captures and procedural notes from both radar stations. Once the entry was finalized, the radar sites reverted to their standard monitoring routines, and operations across the Labrador Shelf transitioned into their usual quiet spring activities. No similar incidents occurred again that week, nor did any subsequent detections align with the same curvature. The final statement in the archival summary reflected the uncertainty of that night without reiterating any earlier phrasing, simply noting that the track represented a controlled high-altitude maneuver without the identification of a corresponding aerospace source within NORAD jurisdiction. In the Central Plains reflective pair detailing the Nebraska and Kansas sector of 1988, the archival reference from the NORAD Continental Surveillance Record indicated that June of that year bore typical high-pressure weather conditions across the central United States. The airspace over Nebraska and northern Kansas remained unrestricted, devoid of convective storm systems, widespread thermal inversions, or any meteorological phenomena capable of inducing radar anomalies. The long-range surveillance radar tasked with monitoring the Nebraska-Kansas sector had been functioning seamlessly for several weeks. Its diagnostic logs reflected consistent transmitter output, stable receiver gain, and a pristine electromagnetic environment. That evening's shift anticipated yet another uneventful cycle of continental surveillance. at 0119 local time. The radar sweep returned two primary traces that emerged simultaneously on distinct azimuth lines, yet at an equivalent altitude. Both returns were sharply defined, indicative of reflective structured entities rather than atmospheric scatter. The measured separation between the two returns was 22 kilometers, and the altitude estimation placed them at approximately 37,000 feet. The amplitude strength of the two traces bore a striking resemblance to each other, implying that the objects possessed similar radar cross-sections rather than a primary return accompanied by a ghost reflection. As the operators moved to the crucial first step, they initiated a system verification. The health of the transmitter was meticulously assessed, confirming that the pulse repetition frequency lay well within established tolerances. There was no irregular drift displayed in the timing circuit, and the speed of the antenna rotation remained true to its calibrated specifications. Internal logs revealed no fluctuations in power, leading operators to affirm that the radar was functioning optimally. They proceeded to capture continuous sweep data, both manually and through the system's automated high-resolution recording apparatus. The subsequent phase involved a thorough clutter assessment. Ground clutter patterns were evaluated and found to align with prior cycles. No new agricultural structures, silos, or other reflective surfaces that could yield erroneous secondary returns had been recorded. An examination of atmospheric conditions showed no signs of ducting or multipath effects, both of which can occasionally result in erroneous reflections. The air current was sufficiently dry and stable, thereby allowing for the elimination of refractive anomalies as a concern for the immediate time frame. The two returns maintained a south-southeast trajectory at a consistent ground speed that persisted across the following four sweeps. Their separation remained steadfast, not fluctuating by even a kilometer. Operators documented the unyielding spacing between the objects, noting an absence of the expected widening or narrowing typical of aircraft responding to minor turbulence or control adjustments. The synchronized movement patterns indicated intentional formation flying. Despite the absence of any scheduled or sanctioned formation activity in the vicinity, nor had the continental United States region been apprised of the situation within a few minutes. The operator dispatched the initial report utilizing the classification assigned to uncorrelated paired returns at altitude. The Command Operations Center acknowledged receipt and commenced the standard multi-station cross-checking protocol. The first installation contacted was the Federal Aviation Administration long-range radar facility in charge of adjacent airspace. FAA controllers corroborated the existence of the same paired returns on their systems, though the amplitude was slightly diminished due to variances in antenna characteristics. They confirmed the identical altitude, spacing, and drift vector, with two radar systems unequivocally observing the same geometrical configuration. The North American Aerospace Defense Command initiated the second phase of procedural scrutiny, seeking correlation with recognized air traffic. Civil aviation databases revealed no commercial flights operating in paired formation at that altitude. The flight routing documentation for the evening contained only standard transcontinental entries situated well south of the detection zone. The military air activity roster showed no tanker tracks, no training sorties, no formation flights, nor strategic aircraft traversing through the Nebraska-Kansas region. At that hour, the nearest United States Air Force base reported no aircraft in the air. There were neither drills, refueling operations, nor escort missions capable of generating two radar targets traveling in tandem. Back at the radar station, the operators scrutinized the phase characteristics of both returns. Neither exhibited the rotational modulation typically associated with weather balloons, nor did they behave like atmospheric interference. The consistency and stability of the returns served as pivotal indicators. Weather clutter tends to exhibit fluctuation. Biological targets, such as migratory birds or larger animal groups, appear at considerably lower altitudes and move unpredictably. These returns, on the other hand, retained their altitude precisely, showing neither ascent nor descent throughout the tracking period. By 127, The objects had crossed into the northern Kansas segment of the sector. The FAA radar continued to monitor their progress, reporting that the signal-to-noise ratio remained high enough to classify the contacts as primary radar reflections instead of artifacts. Analysts from NORAD requested the transmission of raw sweep frames for comparative analysis at a later time. The FAA facility complied, channeling their recordings back through the regional center. The next procedural prerequisite involved cross-checking with additional radar sites. A Western Regional Radar installation was assigned the task of examining its overlapping coverage zone. Within 2 sweeps, that station also affirmed the presence of the 2 returns, adding further supporting evidence that the contacts were not merely localized anomalies affecting 1 or 2 stations. Analysts now had a tri-station verification chain, significantly enhancing the credibility of the detection. NORAD then began to evaluate the potential of aerial vehicles operating without transponders. Though such occurrences are rare, aircraft can occasionally operate without proper identification signals due to equipment malfunctions or intentional non-compliance. However, none of the altitude, spacing, or speed characteristics conform to recognized aircraft performance standards under those conditions. Formation flights devoid of transponder signals would have necessitated military authorization, which was absent in this region. Civilian formation flights at 37,000 feet were effectively impossible due to airspace regulations. The paired returns continued their steady drift south-southeast for the next 8 minutes. Their velocity varied within a narrow bandwidth, demonstrating no indications of acceleration or deceleration. The parallel motion remained precise, with the 22-kilometer separation consistently preserved across each sweep. Such uniformity constituted a distinctive feature of the incident documentation. Natural phenomena fail to uphold fixed spatial relationships with such precision, nor do drifting entities at high altitude exhibit such behavior. Operators continued to collect high-resolution sweeps within the procedural framework. The COENR directed the radar site to assess for potential jamming, electronic interference, or deceptive signal production. Each diagnostic examination yielded negative results. No frequency shifts indicative of deliberate jamming were detected. Angular ripples did not signal any side lobe confusion. The absence of frequency hopping signatures across the site's electronic environment indicated a pristine electromagnetic spectrum. At 135, both returns exhibited a momentary amplitude fluctuation. This disturbance persisted for less than a complete sweep rotation and appeared identical across both objects. The synchronized nature of the fluctuations implied either a shared environmental effect or an intrinsic similarity in the reflective properties of the surfaces. Given that atmospheric data indicated no disturbances capable of synchronizing amplitude shifts across a 22-kilometer expanse, analysts categorized this incident as one of the remarkable features of the case. 2 sweeps later, at 0136, both returns vanished simultaneously. In one sweep rotation, the paired objects maintained stability and coherence. However, upon the next sweep, the radar portrayed a clear, empty sky, devoid of primary returns in their prior locations. The disappearance transpired without any lateral drift, without a reduction in amplitude, and without alteration in altitude. The moment of cessation was instantaneous. NORAD protocol mandated that operators maintain vigilant surveillance over the area for several minutes subsequent to the disappearance. No reappearance was noted. Neither object re-entered the sector from any direction. The Federal Aviation Administration radar systems confirmed the same immediate loss of contact. The radar station located in the west corroborated that the contacts vanished concurrently from its eye display as well, with corroboration from 3 stations regarding both the appearance and disappearance. CONAR commenced the analysis cycle following the event. All radar systems involved provided operational logs. Diagnostics indicated no malfunctions across any of the stations. Maintenance schedules revealed no pending service tasks that might jeopardize detection reliability. Meteorological data once again dismissed any atmospheric explanations. There were no temperature inversions present, no storm fronts approached the area, no cloud layers existed at the altitude where the returns were initially detected. Analysts scrutinized the data for potential signs of multipath reflections. The geometry of the returns rendered this theory untenable. Multipath reflections could not produce two stable, evenly separated objects that drift in tandem before vanishing simultaneously. Likewise, chaff, rocket boosters, or high-altitude debris could not account for the observed behaviors. Debris tends to scatter irregularly and accelerate or decelerate unpredictably. The objects in question exhibited neither behavior. Furthermore, satellite correlation centers were consulted. No low Earth orbit satellites aligned with the sector at the requisite angles to yield symmetrical reflections. There were no scheduled or recorded re-entry events. Infrared missile warning satellites detected no thermal activity. The objects remained cold, silent, and reflective, yet did not exhibit characteristics typical of known aerospace bodies. With all conventional explanations eliminated, NORAD classified the incident within the framework used for paired high-altitude non-operational returns. Such entries were infrequent and generally unresolved. Analysts safeguarded the raw sweep data for potential future comparisons with analogous cases. The radar stations reverted to their routine monitoring after the review cycle concluded. The case was archived not due to any dramatic elements, but rather because no procedural approach could clarify the identities of the two objects that traversed the clear night sky above the Great Plains in perfect synchronicity. Their origins, purposes, and sudden disappearance eluded satisfactory explanation through every phase of analysis. The concluding notation underscored only what remained indisputable. Two coherent reflective bodies appeared together, traveled alongside one another, and vanished simultaneously, leaving no evidence other than the frames that chronicled their fleeting passage. The Elmer Step Climb Tracks, High Arctic 2015. Archival reference, NORAD High Arctic Surveillance Record 1504 altitude, February 2015. The high Arctic night at CFS Alert offered minimal contrast, presenting a vast expanse of darkness extending across the polar plateau. The environment was tranquil and subdued as radar operators preferred, calm winds, no ducting layers, no auroral disturbances, and no severe geomagnetic activities likely to impact the North Warning System. This was one of those rare nights when the radar facility operated for hours without necessitating adjustments due to environmental instability. Shortly after midnight, the sweep cycles remained unblemished, noise levels were minimal, and the display showed only the anticipated traffic far to the south. No indicators suggested that the shift would deviate from routine surveillance. The initial sign of the anomaly emerged at 001. A solitary return manifested at the extreme edge of the high-altitude sector, approximately 60 miles northeast of Alert. This detection was registered crisply as a stable and well-defined radar point at an altitude near 52,000 feet. Operators verified that the amplitude and phase characteristics mirrored those of a coherent reflective body rather than indicating a transient echo. Before classification could occur, the first step mandated by NORAD protocol was to confirm the integrity of the systems involved. The transmitter power remained stable, receiver sensitivity had not fluctuated, timing circuits were intact, and the antenna rotation rate functioned normally. No indications of malfunction were present in the equipment diagnostics. The subsequent two sweeps reaffirmed that the return was not merely a transient blip. The object maintained a steady altitude and exhibited consistent energy reflections across all pulses. Operators initiated a documentation sequence by recording the time of initial detection, estimated altitude, and frequency gain settings. Due to the return's lack of an associated transponder identification, it qualified as an uncorrelated track, thereby triggering the first notification to the Canadian Air Defense Sector. 3 minutes subsequent to the initial sighting, the return executed its first of several abrupt step climbs. Instead of a gradual ascent, the altitude shifted abruptly by an approximate increment of 4,000 feet. a behavioral pattern seldom observed within high-altitude airspace. The radar effectively documented this shift between sweeps, capturing the alteration in altitude without any transitional noting across the ascent trajectory. The change was instantaneous, establishing a second stable elevation at roughly 56,000 feet. Due to the nature of NORAD's procedures, immediate verification from supplementary stations was indispensable whenever sudden high-altitude transitions were registered, particularly when these shifts occurred devoid of an accompanying Doppler signature. Consequently, the command center situated in North Bay dispatched a request to the Hall Beach node for an assessment of the same corridor. Conditions at Hall Beach paralleled those at Alert. The radar data was clear, devoid of weather disruptions or ionospheric aberrations. The station reported no detection to that point, likely because the object remained at the threshold of Hall Beach's sensitivity range. NORAD thus requested continuous surveillance across the forthcoming sweep cycles. Meanwhile, Alert operators meticulously recorded the precise elevation shift and relayed altitude estimations to the air defense sector. 5 minutes after the initial climb, the return initiated its second step-level ascent. Once more, the increase measured nearly 4,000 feet, again without displaying an acceleration curve. The radar exhibited an altitude reading approaching 60,000 feet. Only entities with rigorously controlled lift profiles could achieve such increments seamlessly. Conventional aircraft operating at such altitudes inherently manifest variations due to atmospheric influences. However, the return exhibited neither turbulence-induced fluctuations nor partial descent between sweeps. Maintaining stability upon reaching each altitude, NORAD's correlation protocols mandated cross-referencing satellite data for re-entry signatures, ballistic trajectories, or orbital debris. The space-based infrared system returned no indications consistent with heat bloom or atmospheric friction. There was no evidence of an object traversing the atmospheric interface, either ascending or descending. DSP data revealed merely faint reflective pulses on the optical sensors that aligned with the radar timestamps, yet these lacked a thermal signature. This effectively discounted re-entry vehicles or active propulsion sources that could generate detectable heat as per DSP metrics. By 0028, the object had ascended once more, this time executing a third step-level alteration, which positioned the altitude near 64,000 feet. This ascent was meticulously logged with the same precision applied to the earlier climbs, manifesting between sweeps without discernible transitional motion. The climbing behavior was markedly distinct from turbulent scatter. As environmental reflections do not yield clean altitude transitions symmetrical across sweeps, meteorological specialists analyzing the real-time feed substantiated that no inversion layers existed that could create multiple stacked reflections. Moreover, the radar cross-section remained uniform through each ascent. Atmospheric scatter typically distorts the RCS profile. Nonetheless, the object's reflective pattern persisted solid and compact. In response, the air defense sector instructed alert teams to initiate high-resolution data capture. The radar commenced recording each pulse individually instead of in aggregated sweeps, establishing a more granular record of the occurrence. NORAD analysts typically reserve this mode for imminent threats, peculiar anomalies, or objects necessitating rapid classification. The system began gathering pulse-to-pulse variations concerning amplitude, phase stability, frequency shifts, and polarization response. At 031, Hall Beach radar finally secured the same return. Initially detected faintly at a slightly lower altitude due to angular differences in radar geometry, confirmation arrived in the expected timing range. Within mere seconds, Hall Beach verified that the object was ascending in a pattern consistent with alert recordings. This confirmation elevated the tracking to a two-station correlation, which necessitated escalation to the continental NORAD region. The subsequent step for NORAD involved validating civil and military flight databases. There were no authorized aircraft operating in the corridor. Additionally, no weather balloons had been sanctioned. No high-altitude research vehicles were scheduled. Canadian forces reported no atmospheric sampling missions, and NASA indicated no polar-stirring balloon activities. The U.S. Strategic Command confirmed that there were no missile tests or suborbital research launches occurring. Nothing across North American aerospace operations aligned with the track's altitude, velocity, or step climb behavior. The object sustained its altitude across several sweeps before climbing again, this time reaching approximately 68,000 feet. The raw data disclosed that each climb mirrored the previous, consistently marking an elevation change of around 4,000 feet with each iteration. NORAD analysts observed that such a pattern hinted at an intentional control rather than mere natural drift or environmental interference. Step climbs of this character are a rarity in the archival records, as most uncorrelated high-altitude tracks either drift with prevailing winds, descend along atmospheric curves, or deteriorate due to incoherent reflections. This object, however, ascended repeatedly with geometric precision. By 0037, DSP satellites recorded a subsequent series of faint optical flashes, once again absent of any infrared signature. The flashes corresponded precisely with the timing of the radar climbs, implying reflective surfaces that may have been altering orientation during each elevation shift. Should the object possess external panels, surfaces, or structural geometry capable of reflecting sunlight, these flashes might symbolize momentary alignments. NORAD mandated a comprehensive comparison against known orbital entities. Space surveillance confirmed that no satellites situated within the region matched the altitude or behavior. Any object in a highly elliptical polar orbit would have exhibited substantial velocity. Nevertheless, the radar indicated only a steady, slow horizontal drift, far from any orbital speed. As the object zoomed toward 72,000 feet, both Alert and Hall Beach detected a brief enhancement of brightness within the radar return. No environmental factor could rationalize the sudden elevation in RCS. The operators detected this anomaly, resolutely continuing their tracking efforts. The return veered slightly north toward the polar cap, yet maintained a stable altitude for a prolonged duration. At Donner 045, the return gradually diminished at both stations at once. It neither descended nor accelerated. It merely faded sweep by sweep until its amplitude succumbed to levels below the threshold of detection. The decline was symmetrical across Alert and Hall Beach, indicative of an object exiting radar coverage due to distance rather than system malfunction. NORAD maintained surveillance for 20 minutes, yet the return did not re-emerge. The subsequent morning, NORAD analysts scrutinized recordings from both stations, DSP optical logs, atmospheric measurements, and all correlation data. Every conceivable explanation, including aircraft, satellites, re-entry vehicles, inversion layers, clutter, scatter, and electronic interference, was methodically dismissed. The episode was categorized as a high-altitude multi-step ascent anomaly, one of the rarest classifications within the High Arctic Surveillance Archive. The records were archived in the Polar Surveillance Log, highlighted for its documented controlled ascent behavior and confirmation from 2 stations. In the weeks that followed, no additional detections occurred. The step climb track stood alone in the 2015 High Arctic record, an object that ascended in precise increments toward the pole without generating a thermal signature or correlating with any recognized aerospace activities. It left in its wake only the pulse-level signatures captured by the radars that night, coupled with the optical flashes registered by the DSP satellites. The event concluded with a straightforward notation that echoed the terminology typically reserved for unresolved polar detections of that period, albeit articulated in a unique manner for this instance. It noted simply that the object ascended through multiple altitude layers, devoid of any identifiable source, and exited the surveillance envelope without correlation to any known platform. The North Dakota Stationary Triad. United States of America, 1974. Archival reference. NORAD Continental Surveillance Record 7406GF, June 1974. The Great Plains Air Defense Corridor operated at a standard operational posture, with Grand Forks' air defense sector monitoring the radar sweep cycles along the northern tier. Weather conditions across the region displayed stability: clear skies, minimal meteorological interference, and low wind shear. The long-range ANFPS-35 radar, renowned for its sensitivity to both large aircraft and small reflective objects at moderate altitudes, had been engaged in continuous diagnostics since the commencement of the shift. No calibration drift became evident in the logs. All systems delivered clean, consistent returns. At 21:42 local time, something unusual manifested on the display. It was neither a track nor a conventional return indicative of motion. Instead, 3 discrete radar points appeared simultaneously during the same sweep cycle. They were situated at roughly the same range, yet at 3 distinct azimuths, forming what radar technicians would later characterize as an equilateral geometry across the northern sector of the display. The altitudes clustered around 25,000 feet. Each within acceptable margins of error, yet sufficient to strongly imply that the objects were nearly co-located. The initial procedural action centered on verifying internal integrity. Operators inspected transmitter output power, receiver gain stability, pulse compression, and antenna speed. The readings all fell well within standard parameters. If the return had stemmed from equipment malfunction, irregular amplitude spikes or sweep distortions would likely have been recorded. However, nothing amiss emerged. The 3 points had manifested distinctly, uniformly, and with quantifiable stability. The next step involved evaluating the potential for atmospheric multipath reflections, which could, under rare circumstances, yield phantom duplications. Temperature gradients occasionally result in the reflection of signals at atypical angles, but meteorological data for the region indicated no significant inversion layers affecting the situation. The Air Weather Service affirmed the lack of ducting conditions. Upper air soundings from Bismarck and Minot, issued that evening, revealed consistent lapse rates. Devoid of any unusual stratification capable of trapping or refracting radar energy in a manner that could create stationary triad points. All procedural evaluations suggested that environmental interference was highly improbable. Once environmental factors were ruled out, the radar team proceeded with the correlation protocol. Grand Forks Sector liaised with the North American Aerospace Defense Command's Continental Surveillance Division and submitted an uncorrelated multi-point detection report. NORAD instructed an immediate cross-check with the adjacent surveillance station. Specifically, the long-range radar installation responsible for overlapping coverage in the North Dakota area. That station confirmed the same formation within 2 sweep cycles. The geometry matched precisely: 3 non-moving points, consistent altitude, identical spacing. This validation by a second long-range radar effectively elevated the detection from an internal anomaly to a multi-station confirmed event. NORAD provisionally classified the detection as a non-operative multi-point return. Operators at the second station conducted their own diagnostics, reaffirming the absence of instability in their system and no atmospheric anomalies in their region. Their findings further corroborated the hypothesis that the triad represented 3 distinct external reflective objects. As minutes elapsed, operators noted an unusual consistency. The 3 returns did not waver in response to wind patterns, nor did they shift under upper-level currents. Aircraft at 25,000 feet typically exhibit small yet measurable deviations in bearing due to turbulence or course correction. These 3 points did not exhibit any variability. They retained a fixed position relative to one another, illustrating a geometric stability that was devoid of rotation or expansion. It's a rare sight to encounter stationary aerial objects at such altitudes. Aircraft are incapable of hovering at that height, and neither balloons nor lighter-than-air platforms could remain undisturbed, as they would invariably drift and alter their radar profiles. Such characteristics were distinctly absent. In response to this unusual phenomenon, NORAD's regional command initiated requests for expansive high-resolution sweeps. Technicians meticulously cataloged amplitude, phase stability, and range metrics for each of the 3 points. All 3 displayed almost indistinguishable signal characteristics, characterized by coherent and narrow band reflections, unwavering strength, and an absence of phase scintillation. These attributes implied the presence of some inherently smooth, solid surfaces. Weather scatter typically manifests variability, whereas sea clutter would not be discernible this far inland. Biological targets such as avian populations or large swarms are characterized by constant movement and are not capable of maintaining fixed altitude bands. None of these possible explanations proved valid. The Federal Aviation Administration Air Traffic Control Center managing the northern aircraft was contacted to examine their long-range tapes. While their equipment was not as finely tuned for intricate returns, it managed to detect faint reflections that spatially aligned with the Grand Forks data. The FAA confirmed that no aircraft had been authorized to operate within that sector at 25,000 feet, and no transponders had been activated in that area. Moreover, no commercial flights reported having observed visual anomalies or unusual lighting. During the subsequent phase of NORAD procedures, analysts began exploring the likelihood of missile tests or foreign surveillance missions. Strategic Air Command reported no aircraft in the vicinity, with no tanker routes traversing that altitude over North Dakota at the time the detection occurred. There were no ballistic missile tests on the schedule, and no re-entry bodies had been tracked entering the atmosphere above the continental United States. Any foreign aircraft breaching U.S. airspace would have been detected along prior radar corridors. The lack of any inbound tracks before the triad's emergence dismissed the notion of high-altitude penetration flights. The objects maintained their stationary status for nearly 9 minutes, with the separations between the 3 returns holding constant to within 1/10 of a nautical mile. This fixed spacing provoked further inquiry. Had the returns been reflections created by tripath scattering from a singular physical source, predictable amplitude ratios would be expected to fluctuate. Instead, each return sustained an almost identical strength. This symmetry cast doubt on the validity of standard reflection models, compelling operators to maintain their focus on monitoring the formation while also requesting satellite assistance. Support from Defense Program infrared satellites covering the area revealed no heat signatures indicative of aircraft or propulsion systems. While this finding excluded the possibility of jet engines, it did not entirely negate the chance of cold, non-emissive bodies, given that DSP systems are designed to detect thermal emissions rather than reflective light. The lack of thermal signatures provided no affirmative identification, but confirmed the absence of conventional aircraft involvement. At 21:51, the first irregularity transpired. The northernmost point slightly dimmed across one sweep before returning to full amplitude on the next. Operators scrutinized for calibration jitter and receiver drift. However, the logs indicated no variance. The amplitude fluctuation endured for merely a single sweep and did not recur, while the 2 other points remained stable. NORAD analysts noted this fluctuation, yet could not attribute it to known causes. The duration was too brief to suggest deterioration of the signal source and did not align with patterns typically associated with equipment artifacts. It was recorded in archival notes as an isolated amplitude variance. At 21:54 local time, all 3 returns vanished within the same sweep cycle. They did not fade gradually, nor did they shift or scatter. Their disappearance occurred instantaneously between one rotation of the antenna and the subsequent one. The simultaneous cessation carried significant implications. Atmospheric reflections typically fade gradually, and aircraft departing the coverage area display transition lines or displacement before becoming untraceable. Equipment malfunctions do not remove 3 distinct points in perfect synchronicity. The sudden nature of the disappearance only amplified the anomaly's classification, prompting the radar crew to continue monitoring the region as dictated by NORAD protocols. The vicinity remained clear. No secondary reflections emerged to fill the void. The adjacent station corroborated the termination occurred at precisely the same moment. FAA radar ceased detecting the faint signals, and no pilots reported observing unidentified lights or objects. The formation had materialized without prior introduction and vanished without leaving a trace. Post-termination, the analytic cycle commenced. Radar engineers delved into internal logs, verifying transmitter coherence, pulse timing, and antenna rotation without discovering irregularities. Atmospheric records maintained their stability. Meteorological analyses found no explanation for a stationary triad at that altitude, with no storms, wind shear, electrostatic effects, or inversion layers identified. Satellite data corroborated the absence of high-altitude entities capable of yielding the detected patterns. Ultimately, the concluding review determined that the formation's geometry, stability, altitude, and abrupt cessation were inconsistent with any known atmospheric or technological explanation available in 1974. This case was classified as an unresolved multi-point stationary formation, archived as part of the Continental surveillance records. Subsequent nights did not yield similar occurrences, and no related anomalies were later linked. Instead of drawing to a conventional conclusion, the final entry in the 1974 Continental log simply noted the detection's geometric stability, multi-station verification, and absence of an identifiable source, leaving analysts with a case characterized not by its complexity, but by the precision with which it eluded explanation. The Unova Bay Descent Line, Quebec, 1999. Archival reference, NORAD, Eastern Surveillance Record, 1999, Z4UB, April 1999. Unova Bay remained enshrouded in the lingering chill of late winter. Yet the skies were sufficiently clear that the radar horizon spanning northern Quebec displayed almost no interference. The long-range site monitoring that sector operated faultlessly across numerous consecutive shifts. Sweep integrity maintained stability. The signal-to-noise ratio was low, while environmental readings indicated one of the calmest nights of the season. There were no geomagnetic disturbances detected, no inversions strong enough to create ducting, nor any fronts traversing through the eastern Arctic corridor. As a result, the Eastern Air Defense Sector classified the region under optimal surveillance conditions. At 21:41 local time, a high-altitude return emerged near the upper boundary of the radar's expansive reach. It appeared on the display as a precise and compact trace positioned near 72,000 feet, well above the altitude window utilized by any scheduled air traffic that evening. The object maintained stable amplitude across the initial 3 sweeps, demonstrating coherence and a solid cross-section. The detection did not waver, as one might expect from drifting particulates or sporadic atmospheric scatter. Operators carefully logged the initial coordinates and promptly initiated system status verification following standard protocol. The radar's transmitter power remained at nominal levels, pulse timing held steady, and phase noise remained well within tolerable limits. There were no signs pointing to calibration drift or intermittent receiver gain. As the site confirmed the integrity of its instrumentation, the return exhibited its first peculiar attribute, a consistent, continuous descent. NORAD's altitude tracking functions plotted the object's descent in a uniform slope, descending from 72,000 feet. The descent rate was slow enough for precise tracking, yet steadfast enough to classify it as controlled movement. No sudden drops, no accelerations, and no oscillations in vertical speed were apparent. A ballistic object would have resulted in a sharply curved trajectory along with rapid changes in velocity. Likewise, a meteor would have produced plasma interference or fragmentation indicators. This return reflected neither of those characteristics. At 21:42, Cape Dyer, situated to the northeast, received directives from the Canadian NORAD region to scrutinize the corresponding sky sector. Their radar identified the same descending track 1 sweep later, with the altitude and position aligning flawlessly with the readings from the Quebec installation. The 2-station confirmation escalated its classification from a mere uncorrelated return to an actively tracked aerial object requiring continuous attention. Operators at both radar sites engaged high-resolution logging. The radar cross-section of the object remained consistent as it descended, as though the reflective surface retained orientation relative to the radars. There was an absence of tumbling or rotation. The amplitude did not falter, broaden, or diminish. This clean, uninterrupted radar profile became a defining hallmark of the case. Following NORAD protocol, the Eastern Air Defense Sector sought atmospheric re-evaluation from the Canadian Meteorological Office. Reports confirmed the lack of inversion layers capable of generating false vertical returns. Upper-level winds were moderate, insufficient to distort or contaminate the signal. The atmosphere above Angava Bay remained dry, further minimizing the possibility of mixed-layer reflections. No data in the environmental readings corresponded with the object's peculiar behavior. At 2144, the object descended through 60,000 feet. Its descent continued as smooth as before, following the same straight trajectory with a steady vertical rate. Had it been debris re-entering the atmosphere, sensors would typically detect heating signatures or variations in radar reflectivity as surface material burned away. Yet both radar stations recorded absolute stability and amplitude. There were no accompanying ionization markers, erratic changes, or expanding radar traces. NORAD's correlation team commenced an exhaustive sweep of all potential catalog matches available. No commercial flights occupied northern Quebec. Military activity within the region was non-existent. There were no scheduled high-altitude research aircraft. No foreign surveillance missions received authorization. Satellite tracking centers verified that no objects were decaying from orbit along a trajectory congruent with the descent line. If the return had represented re-entry debris, orbital elements would have been pinpointed long before the object entered NORAD's envelope. The absence of thermal signatures contradicted that scenario. By 2146, the descent reached 40,000 feet. Cape Dyer's operators noted that the cross-section still maintained its compact definition. The Quebec site observed no angular displacement or deviation in azimuth. The track line sustained as a clean downward slope. Data from the FAA for the area, accessed through interagency channels, revealed no associated high-altitude returns on their systems. The object existed solely within the confines of the long-range military radars. As it continued its descent, the operators conducted repeated system checks. They assessed transmitter waveguides, sweep timing, receiver front-end performance, and antenna rotation stability. Each verification met the standards. The possibility of a dual-station equipment malfunction remained exceedingly low, especially considering that both systems' diagnostic logs coincided with normal operations. At 2147, the object passed below 30,000 feet. Its descent remained so consistent that each radar sweep perfectly matched the anticipated position from the prior sweep. This degree of predictability manifested as an anomaly in radar returns that was indeed rare. Generally, unknowns in northern sectors exhibit erratic behaviors, drifting and swaying due to atmospheric conditions. Remarkably, the Angava Bay return adhered to a geometric descent trajectory with a precision that defied easy classification. Responding to this peculiar phenomenon, Hopedale, a radar station situated farther south, received directives to scan its northern sector for any signs of acquisition. Upon completion of the next sweep, the return appeared on Hopedale's scope as well. With 3 stations now corroborating the identical descent pattern, the classification of the object gained credibility, necessitating an expansive review by NORAD. The Canadian NORAD region promptly requested an immediate cross-check via satellite. DSP infrared satellites commenced analysis of the coordinates for any heat-related activities. Their sensors returned inconclusive results. No trace of a plume, no infrared spikes, and no detectable heat emissions emerged from an object on its descent, plummeting from 72,000 feet to below 20,000 feet. Analysts found the absence of such signatures to be profoundly unusual. Any widely recognized aerodynamic or high-speed vehicle should have produced some thermal signatures while traversing those altitudes. By 2149, the object crossed below the 20,000-foot threshold. The downward trajectory continued without interruption. All stations observed a lack of lateral deviations. Hopedale noted the vertical descent rate neither accelerated nor decelerated. Its consistency prompted analysts to label the descent profile as engineered, even though that phrasing did not make it into the final report. The return continued its descent until it hovered just above 18,000 feet. As the next radar sweep initiated, the return remained distinctly visible. Upon completing its antenna rotation, the radar anticipated the subsequent downward shift. However, to the collective astonishment of the analysts, the object simply vanished. There was no sign of distortion prior to its disappearance, no tapering effects or widening of the trace. The return collapsed within a single interval of the sweeping motion. Cape Dyer confirmed the same abrupt termination, and Hopedale echoed this assessment mere seconds later, stating that the object had entirely vanished from its display. The concurrence of all three stations regarding this sudden loss fortified the conclusion that the cause lay outside equipment failures. Consequently, NORAD activated its post-event protocols. Each of the radar stations submitted timely captures of their synchronous sweeps. Equipment diagnostics from every site indicated normal operational status with no anomalies, no dropouts, and no discrepancies in clock timing. Weather logs confirmed a stable environment. Meanwhile, satellite logs revealed no activities linked to re-entry instances or the presence of orbital debris. Moreover, no aircraft reported sightings of unusual lights or objects in the vicinity. Neither did any marine craft operating in Unova Bay report atypical radar contacts. Analysts began reconstructing the descent path, utilizing data from all participating radar systems. Remarkably, this reconstructed line was smooth, constant, and entirely continuous. The analysis showed no kinematic irregularities or any detectable accelerations. The slope bore no resemblance to aerodynamics or ballistic trajectories and exhibited no characteristics typical of satellite re-entries. Furthermore, the return did not correlate with any documented atmospheric phenomena observed in the northern sectors. NORAD's evaluation reached the conclusion that the return neither aligned with any recognized aerospace activities. The case file outlined the absence of thermal signatures, the flawless verification across multiple stations, and the engineered descent profile as the three critical unresolved elements. Ultimately, analysts classified it as a non-attributed multi-station descent anomaly lacking any environmental or operational explanation. As the radar stations reverted to their routine surveillance, similar descent lines did not appear in the ensuing days. The phenomenon thus remained an isolated incident, thoroughly documented yet unresolved. Notably, the final entry in the archival summary slightly diverged from the conventions established in earlier decades. It succinctly posited that the object's descent occurred across three independent NORAD stations with a stability that could not be attributed to any known aircraft or atmospheric causes, noting that subsequent activity matching its characteristics was never encountered in the region. The archive referenced the Tuktoyaktuk Line of Bearing Event, Northwest Territories, 1989. This archival record was categorized under NORAD Northern Air Surveillance, reference number 8910 TTK. Throughout the evening, Tuktoyaktuk's long-range radar station had established a steady nighttime tempo. The atmosphere above the Beaufort Sea remained tranquil, with only a gentle upper-layer wind pushing southeastward toward the Mackenzie Delta. By late evening, indicators within the station's ANFPS 117 system exhibited the kind of stability that operators favored. There were no inversion layers, no refractive anomalies, and no ionospheric disturbances cascading down from the pole. Expecting a quiet shift, the radar teams noted that most transpolar traffic navigated well above their operational ceiling, while civil aviation across the western Arctic seldom flew close enough to evoke anything other than predictable radar traces. However, at 21:52 local time, that routine shifted dramatically with the emergence of a single, narrow return. The trace manifested as a line of bearing reflection, lacking any defined track across azimuth. Instead, it sustained its position on the bearing indicator, as though something reflective were moving directly toward the radar's bore sight. Genuine approach returns rarely occur in northern stations, as most aircraft enter the region at angles rather than on a direct bearing. Confirming system performance became the priority. Power output maintained its nominal value. Timing circuits showed no drift. The signal processor registered no pulse compression anomalies. The radar functioned entirely within its operational tolerances. Despite the faintness, the bearing line persisted without fluctuation, ruling out brief effects generated by temperature gradients above the sea. The return appeared coherent, displaying amplitude characteristics aligning more with a physical reflector than the artifacts of multipath scatter or ground echoes. The altitude estimator failed to produce a reading, which was an anticipated outcome for a line of bearing contact. The operator dutifully logged the event and initiated the standard NORAD notification protocol. At 21:54, the Arctic Regional Surveillance Center acknowledged the report from Tuktoyaktuk and instructed the station to uphold full sweep capture. They also communicated the contact to the radar installation in Inuvik, situated approximately 100 meters to the southwest. Should the object represent a legitimate approach, Inuvik's radar would register the return along the same bearing line after several sweeps. Meanwhile, Tuktoyaktuk commenced an examination of the environmental data provided by the meteorological unit. Conditions overall remained clear with surface temperatures stable. No clouds capable of inducing ducting were present over the Beaufort Sea, and solar activity was low, effectively removing the possibility of auroral interference. By 21:56, the return exhibited a slight strengthening. This effect, though subtle, was measurable. The amplitude increased marginally, hinting that the reflective body was closing the distance from the radar's position. The geometry maintained a consistent alignment with an object approaching directly towards the station, rather than traversing laterally. Operators diligently monitored the signal processor for indicators of movement. The processor did not identify any shift across the range bins. The absence of lateral propagation indicated that the return remained a pure bearing line. Such contact warranted meticulous analysis, as it could signify either a true head-on approach or an exceptionally stable atmospheric reflection. The persistent coherence leaned favorably towards the former interpretation. By 21:58, Inuvik reported its initial sign of a match. Their radar displayed a bearing line on the same azimuth with an identical faint coherence. The offset between the two stations suggested that the unknown reflector was positioned over the edge of the Beaufort Sea, to the north of the Tuktoyaktuk Peninsula. Inuvik's technical supervisor confirmed that their system was operating without issues. Diagnostics mirrored those of Tuktoyaktuk, with both stations detecting a remarkably similar return structure. The regional center elevated the classification to an uncorrelated approach contact and forwarded the unfolding situation to the Alaska NORAD region. Analysts at NORAD initiated the first correlation cycle. Civil aviation controllers verified that no aircraft were inbound on any paths that could correspond to the observed bearing. Logs of military operations revealed no patrols or transit flights in the vicinity. Furthermore, representatives from the maritime sector confirmed that no surface vessels operated radar systems robust enough to yield anomalous reflections. Weather radar feeds from Environment Canada displayed no unusual formations. The regional command ordered continuous monitoring of the situation. At 22:03, the return became more defined as amplitude increased once again, indicating that the reflective object was progressing closer. Operators remained vigilant for the transition from a bearing line signature to a fully resolved positional track. Most approaching aircraft or objects typically exhibit slight azimuth shifts due to wind drift or minor navigational adjustments. Observations of this contact demonstrated no such movement. The bearing remained locked in place. This stability was unusual and incongruent with typical aircraft behavior. The object did not emit any transponder code. Responses from Mode A, Mode C, and military switching channels were eerily silent. The radar showed no IFFF response, and analysts confirmed that no scheduled transits from foreign or allied forces were planned within the corridor. The object did not correlate with any orbital tracks. Satellite predictions from the Space Surveillance Network indicated no debris or low-orbit satellites intersecting the line of bearing at the necessary angle. By 2207, the return intensified yet again. Tuktoyaktuk observed an increase in amplitude, surpassing the threshold generally associated with distant sea clutter. A growing return devoid of lateral movement suggested a physically coherent structure advancing along a precise vector. Inuvik's radar corroborated this identical growth. The regional center began preparations for the next stage alert, which entailed notifying additional nodes in case the contact evolved into a clearly defined track. No intercept request was issued due to the absence of established speed, altitude, or identity, and since the approach vector had yet to demonstrate any threatening movements. At 2229, technicians at Tuktoyaktuk detected a brief flicker in the return. This flicker did not resemble atmospheric scintillation or ground interference. Instead, the signal seemed to fluctuate as if the reflective surface had briefly shifted orientation. Then, just as abruptly, the amplitude stabilized once more. A limited number of historical NORAD cases document similar momentary fluctuations which resist attribution to turbulence or clutter. This flicker was duly logged in the event summary. At 2211, the return peaked at its highest amplitude, remaining locked on the same bearing. No azimuth movement was observed. The object had neither adjusted altitude nor drifted. The signal processor displayed an exceptionally consistent phase pattern, indicating a structured body capable of consistently reflecting radar energy. Typically, a return approaching at any horizontal velocity would have resolved into a track, yet that transition never transpired. At 2213, the return began to diminish. This attenuation was not gradual, but rather rapid, occurring over 2 sweep cycles. A return that approaches from a distance does not necessarily weaken while closing the gap. This alteration suggested that the reflective body had modified its radar profile or orientation. Operators prepared for a positional shift, only to find that the return simply vanished. One sweep displayed a coherent bearing line, while the next revealed nothing. Inuvik confirmed the disappearance simultaneously. No lingering reflections persisted on either system. No secondary contact drifted across the range. The return was entirely gone. NORAD directed both radar stations to sustain monitoring for a potential reappearance. The meteorological unit reconfirmed environmental stability, with no fronts, no temperature shifts, and no refractive layers capable of generating or erasing long-duration bearing lines. Civil and military aviation channels lay dormant. No pilots reported sightings of unusual lights or extraordinary occurrences. The maritime sector affirmed a lack of counterpart activity on the surface, leading to a sustained silence in the region. By the time the clock struck 11:30, no reappearance was recorded. Accordingly, the regional center activated the complete analytic protocol. Tuktoyaktuk shared its comprehensive sweep logs, calibration data, and diagnostic messages spanning the event window. In response, Inuvik's compiled and submitted its own data package. Technicians at NORAD meticulously examined both assortments of raw radar captures. Throughout the analysis, equipment performance remained within acceptable parameters with no indication of timing errors or multipath distortion surfacing. Every sign pointed away from mechanical or software anomalies. The stability of the bearing line and the amplitude pattern suggested the presence of a reflector exhibiting a consistent radar cross-section. Atmospheric reflections typically fail to maintain coherence across extended time frames. Ground reflections oscillate based on height and angle, while multipath scatter is ever-changing. None of these variables matched the behavior that had been observed. Analysts at NORAD juxtaposed the event against previous bearing line contacts archived from the northern belt. A mere handful showcased comparable characteristics. Those infrequent instances involved stable, enduring bearing returns that appeared to strengthen as if approaching, yet never coalesced into fully resolved tracks. None of these earlier anomalies could be attributed to aircraft, satellites, or atmospheric phenomena. In concluding their assessment of the Tuktoyaktuk event, evaluators remarked that the return exhibited properties typical of a controlled and stable reflective object. The reasons behind its disappearance remained undetermined, with the contact not aligning with any recognized aerospace activity at that particular time frame. The final review merely noted that the object had neither traversed the coastline nor shifted across the range, failing to correlate with civil, military, or environmental data. The record was meticulously archived in the Northern Surveillance Repository, retaining an exact alignment with its operational logs. This case persisted as one of the quietly tenacious anomalies interspersed within the radar history of the Western Arctic. A stable approach pattern return depicted intent in the absence of motion, power without resolution, and an exit that left no remnants behind. As you may already be drifting into dreams for those still engrossed in the waking world, we shall delve into more narratives, fragments of enigmas remaining unresolved. The Montana Midnight Cluster, 1978, within the Malmstrom Sector, USA. Archival reference, NORAD Western Air Defense Surveillance Log, 7809 MMT. The plains of central Montana nestle into a profound darkness following sunset, a veil that renders the landscape seemingly boundless. Rolling fields, meandering ranch pathways, and the faint outlines of missile support edifices compose one of the USA's most sensitive defense grids. During the late 1970s, this area was the stage for an extensive network of Minuteman missile silos, all commandeered by Malmstrom Air Force Base. Each silo was isolated and fortified, linked to subterranean command capsules manned continuously. Above this intricate network, radar operators integrated into the Western Air Defense Sector of NORAD kept a vigilant watch over the airspace, scrutinizing patterns that conform to the established rhythms of military and civilian aviation. Most nights unfolded predictably, with radar sweeps revealing the customary signatures of small civilian aircraft, sporadic tanker traffic, and the distant arcs of airliners traversing the expanse between coasts. When an anomaly surfaced, operators were trained to dissect it with precision. It was amidst such a night shift in 1978 that operators recognized 3 stationary radar returns positioned over distinct nodes of the missile field. Each return manifested at an equal altitude, remaining stationary without lateral drift and reflecting radar energy with sharpness reminiscent of a compact metallic craft. Stationary returns were not entirely uncommon. However, these did not function like typical clutter. They lacked the sway or pulse typical of interference. Rather, the returns remained steady and coherent, behaving similarly to genuine aircraft, but devoid of the anticipated transponder signals. Operators promptly began routine system diagnostics, recalibrating gain settings, and conducting confirmation tests. Every metric indicated that the radar system was operating optimally. The 3 objects steadfastly occupied their positions. The distances separating them constituted a rough triangular formation across the missile field, with each return distanced by several dozen miles. Despite this separation, radar readings indicated a shared altitude with remarkable precision. This symmetry was indeed striking. Operators made immediate notifications to their supervisor, who initiated a correlation check with the broader NORAD network. The Western Air Defense Sector relayed the coordinates to adjacent radar stations for confirmation. In response, 2 remote long-range radars in neighboring sectors verified that they, too, were detecting the same 3 returns positioned identically. While NORAD undertook verification of these contacts, a surface-level patrol from one of the missile alert facilities communicated with radio. Security personnel reported witnessing white-blue lights hovering in a triangular formation above one of the solitary silos. Their descriptions matched closely with the radar returns, noting that the lights did not pulse like aviation strobes. They emanated a steady glow, with observers noting the absence of sound, no discernible structure behind the lights, and no movement characteristic of helicopters. One of the security patrol members conveyed to his shift supervisor that the lights were unwavering and radiant, as if affixed to something. His account surfaced months later in a brief internal memorandum summarizing the night's visual reports. Inside the NORAD radar room, the 3 returns remained unchanged, suspended in place as the operators continued their cross-checking endeavors. Each return reflected radar energy within the narrow band associated with metallic bodies approximately 10 to 20 meters across. This size surpassed that of drones and displayed too much stability to be balloons. The altitude readings remained consistent, and the distances between the objects showed no signs of variation. For an extended period, the scene persisted in the same state. Eventually, however, the radar returns began to exhibit change. In an unexpected moment, all three objects shifted laterally with fluidity, as if propelled by a controlled force. They maintained their relative distances from one another, forming a drifting triangular arrangement above the missile field. Radar operators meticulously monitored the movements. The returns exhibited behavior unlike typical interference patterns. Their transitions were synchronized, directions precise, and their reflectivity constant. Ground personnel at the missile alert facility observed the same transition. The lights glided in unison before once again halting above distinct segments of the missile grid. These lights remained sharply defined. Observers noted that their brightness did not fluctuate erratically, but instead emanated a faint pulsing glow, reminiscent of earlier sightings in the northern tier during the mid-1970s. Given the proximity of the objects to nuclear silos, established protocols mandated immediate notification to Air Force Command. The Western Air Defense Sector communicated a situational overview to NORAD's Correlation Center. While the objects displayed no overtly hostile behavior, their presence above sensitive installations necessitated an elevated precautionary state. No fighter jets were dispatched since the objects had generally remained stationary and manifested no signs of aggression. Instead, NORAD chose to maintain surveillance, vigilantly tracking any alterations in altitude or structure. As the objects lingered above their new positions, NORAD received further validation from nearby radar installations. All readings confirmed the return's stability. Their altitudes aligned precisely. The configuration of their formation held steady at uniform distances. Analysts within the correlation cell meticulously chronicled the unfolding event in real time, reflecting on the multi-radar confirmations and the consistency of the returns. The absence of transponder signals was noted prominently. The objects were classified under the terminology commonly reserved for unknown tracks, or uncorrelated targets. After hovering for an extended duration, the three radar returns initiated an ascent. Radar personnel scrutinized the rise closely. The ascent was gradual, vertical, and rapid. The formation remained cohesive, with each return preserving consistent separation and altitude in relation to one another. This ascent pattern did not align with the recognized flight characteristics of helicopters or fixed-wing aircraft. The climbing rate surpassed the performance metrics of typical aircraft operating at that altitude. Observers on the ground also bore witness to the ascent. The lights, appearing as white-blue points, ascended, shrinking in visible size until they transformed into small, stable stars, ultimately disappearing completely. Many witnesses later recounted that the lights made no noise during their departure. Their recollections resonated with those documented in various Northern Tier incidents from the 1970s, including those at Loring, Wurtsmith, and Grand Forks, all of which featured silent motion over critical installations. Radar systems verified their disappearance. As the objects ascended beyond the radar's effective ceiling, their returns gradually diminished until they disappeared from the screens entirely. This vanishing act was corroborated simultaneously by multiple radar systems. Operators logged the last known coordinates and documented the event's overall duration, noting that the targets were visible on radar for a significant span of time. In the hours following the incident, NORAD analysts commenced an in-depth review of the data gathered. Engineers from the Western Air Defense Sector scrutinized the radar logs for indications of malfunction, yet calibration checks revealed that the system had operated normally throughout the incident. Environmental data underwent thorough examination. There were no temperature inversions, no plasma ducting, and no geomagnetic disturbances capable of inducing false returns. Weather conditions remained stable. Even data from the Defense Support Program satellites underwent verification, but no infrared signatures were detected that correlated with the presence or departure of any known aircraft or debris. Plans for flights throughout the surrounding area were meticulously scrutinized. No military or civilian aircraft were detected within the vicinity during the incident. No training operations matched the recorded coordinates. No weather balloons had been launched. The absence of any correlated flight data further reinforced the classification of the tracks as uncorrelated targets. The summary prepared by NORAD for the Operations Division presented the facts devoid of interpretation. 3 radar returns were recorded at matching altitudes over the Minuteman missile sites. Multiple radar systems confirmed these returns. Ground security personnel described visual observations of white-blue lights exhibiting structured formations. The objects hovered, maneuvered in formation, and ascended before vanishing from radar coverage. No system malfunctions were identified. No aircraft matched the specifics of the event. Identification remained elusive. Although the occurrence was not disclosed to the public, it circulated informally within Air Force security circles, often discussed alongside the earlier series of Northern Tier incidents from that decade. Analysts later reflecting on historical data noted that the geometry, behavior, and clustering of the objects bore striking resemblance to those earlier events. Nevertheless, the Malmstrom incident stood as a distinct case, archived under its reference within the NORAD Western Air Defense Surveillance Log. Following the incident, operations gradually resumed to their typical state. Missile crews reverted to their standard procedures, while radar operators persisted in their nightly scans, yet those individuals who manned the console that night retained vivid memories of the clarity of the returns. The objects had not flickered or drifted as ground clutter tends to do. They maintained their positions with exactness, moved with intent, and vanished just as deliberately. The last entry in the surveillance log reflected this, its notation succinct and aligned with NORAD's standard operational procedures. No correlation was found with known aircraft or meteorological phenomena. Event recorded for reference, the Hudson Valley UFO wave lasting from 1982 to 1986 in Hudson Valley, New York, USA. A woman from Hopewell Junction contacted the authorities, her voice steady yet trembling as she informed the dispatcher of something that was hovering ominously over the trees behind her home. She described it as large, truly massive, and completely silent. Moments later, another call came through, this time from a man traveling along Route 9 who reported, "It's directly above me now." A triangular shape with enormous lights encircling it compelled him to pull over. He insisted that someone needed to be dispatched immediately. Following that, another call arrived, followed by 10 more. By 9:09 p.m. on March 24, 1983, the Yorktown Heights Police Department found itself inundated with a deluge of eyewitness accounts. By 9:30, the roadways were choked with stationary vehicles, their occupants pointing skyward. People congregated on their front lawns, in meadows and atop roofs, all fixated on the same sight, a vast, soundless craft embellished with prismatic lights. Gliding through the night sky like a spectral apparition fashioned from metal and glass. This was not an isolated incident. It was far from a hoax, and it was poised to continue making its presence felt. What began as an unusual report in late 1982 would burgeon into a phenomenon spanning years. Witnesses from dozens of towns recounted hundreds of sightings. An event now referred to as the Hudson Valley UFO wave. The first extensively publicized sighting occurred on December 31, 1982. While many were celebrating New Year's Eve, the residents of Kent and Brewster, New York, were looking up in trepidation. They described a boomerang-shaped craft of significant proportions, adorned with rows of lights along its underside as it hovered slowly yet silently, just aloft the treetops. For some, it passed directly overhead. For others, it hovered long enough for neighbors to assemble outside and observe this unusual sight together. Local police departments, particularly those serving Putnam and Dutchess counties, were inundated with calls, with officers on duty that night confirming that dozens of reports had come in within the span of just 1 hour. One deputy, responding to a report concerning a possible downed aircraft, encountered no debris, but verified that an unusual object had passed overhead. Throughout 1983 and into 1984, the frequency of sightings saw a considerable uptick. Descriptions of the aerial phenomenon remained remarkably consistent, often reported as a V-shaped or boomerang-like entity equipped with white and colorful lights, sometimes flashing or rotating. It was invariably silent. In certain instances, it hovered for several minutes before accelerating swiftly and disappearing, while in others, it seemed to shadow roads or glide through river valleys. The sheer volume of witnesses soon attracted attention that extended far beyond the confines of Hudson Valley. On March 24, 1983, the same night of the dispatch overload, over 300 residents across multiple counties claimed to have observed the object, many relaying similar patterns in their accounts. It would emerge gradually, linger above them, then glide away without a whisper. Some estimates suggested it was as large as a football field. Drivers halted their vehicles, climbed atop hoods, and pointed in sheer disbelief. Among them were professionals from various fields, including engineers, scientists, and pilots. A local air traffic controller, who opted to remain anonymous, later confessed to observing the object through binoculars from the tower window, but found it impossible to classify it as any familiar aircraft. Remarkably, it did not appear on radar. A CBS News crew arrived in April 1983 to interview witnesses, broadcasting numerous first-hand accounts, including that of a retired commercial airline pilot who asserted that the object bore no resemblance to anything he had encountered in all his years of flying. He underscored its capacity to glide in total silence and remain motionless, characteristics absent in conventional fixed-wing aircraft. Photographic evidence began to surface, though many images proved inconclusive. A handful of long exposure photos managed to capture light patterns suggestive of a sizable craft. One particularly noteworthy image taken by amateur astronomer Andrew Grunwell depicted an arc of lights traversing the night sky in a consistent curve, supporting the hypothesis of a solid object rather than multiple aircraft. Investigators from the Mutual UFO Network, MUFON, and the Center for UFO Studies, CUFOS, deployed teams into the area, conducting interviews with witnesses, mapping sighting locations, and meticulously recording times, weather conditions, and descriptions. What emerged was a coherent timeline featuring repeated occurrences, with clusters of activity surfacing every few weeks, predominantly on clear nights. In May 1984, the journal News initiated a week-long series examining the phenomenon, publishing interviews with over 50 witnesses, inclusive of law enforcement personnel. Initially skeptical, local police began taking the reports much more earnestly. Officers responding to multiple calls admitted to having observed the object themselves on various occasions. One officer depicted it as akin to a floating city, vast, slow-moving, and utterly silent. Skeptics pointed toward a local assembly of ultralight aircraft enthusiasts as the probable source of the sightings. Led by Howard Stein, a licensed pilot from Poughkeepsie, the group had allegedly flown in formation, their craft equipped with colored lights. In subsequent interviews, Stein asserted that many of the reports could indeed be attributed to his group's aerial stunts, particularly those launched from a private field in Stormville. However, despite Stein's claims, many researchers and witnesses contended that this explanation did not account for the majority of the sightings. Ultralight aircraft possess inherent limitations in terms of their operational range, lacking the ability to hover or fly safely at night without the requisite FAA clearance. Additionally, the majority of ultralight vehicles are unable to support the weight of extensive lighting apparatus, nor can they achieve the silent flight quality described by numerous trained observers. In one particular inquiry, aviation specialist Philip Embro interviewed various witnesses, each boasting decades of military aviation experience. These individuals expressed unwavering confidence that what they had witnessed was not a fleet of diminutive planes, but rather a singular, substantial object adorned with synchronized lighting patterns. Examination of air traffic logs from Stewart Air Force Base and Westchester County Airport revealed no unusual military or commercial activity during the peak hours when sightings were reported. Requests made under the Freedom of Information Act to the FAA and NA unveiled no classified operations or recognized experimental aircraft movements within the region. By 1985, reports of sightings had begun to wane in frequency, yet they had not completely ceased. Isolated accounts persisted throughout the 1990s, many mirroring the fundamental characteristics of earlier reports. One notable sighting from 1992 reflected the phenomena observed a decade prior. A slow-moving, silent entity gliding over a rural thoroughfare near Pine Plains, witnessed by a mother and her teenage son. Their renderings of the object bore a striking resemblance to a multitude of sketches gathered years earlier. The Hudson Valley Wave has since been extensively chronicled in books, documentaries, and articles. The late J. Allen Hynek reviewed several of the initial reports prior to his passing and regarded them as some of the most credible he had encountered, asserting that the consistency of accounts, the sheer number of witnesses, and the absence of psychological assessments indicating mass hysteria all implied that something genuine had transpired. Exactly what, however, remains elusive. No official explanation has surfaced, and no experimental crafts have been publicly acknowledged that would match the described behavior. Furthermore, no hoax has been identified that could sufficiently account for the extensive scale and duration of the sightings. Even today, the Hudson Valley UFO wave stands as one of the most thoroughly chronicled and compelling instances of prolonged multi-year UFO phenomena in contemporary history. It eluded conventional explanations, engaged thousands of reputable witnesses, and unfolded not in obscurity, but in plain sight, just north of New York City. A retired engineer who witnessed the object in 1984 articulated it best in a 2007 interview. People often question why no one captured definitive proof, and he retorted that they had. They all witnessed it with their own eyes, rendering additional evidence unnecessary. The skies fell silent once again after 1986. However, for many residents of the Hudson Valley, the memories of what they observed have lingered. In August 1950, a formation was sighted over Great Falls, Montana, where two luminous disks emerged from the west, maneuvering in perfect sync, like sunlight reflecting off identical surfaces. General Manager Nick Mariana of the Great Falls Electrics Baseball Club provided an eyewitness account, recalling the afternoon of August 15th in 1950. The skies were fair and dry over Great Falls, Montana, with the sun shining brightly over the Missouri River Valley, imparting a radiance that seemingly washed out the colors of the surrounding hills. From the roof of Legion Stadium, where the minor league team practiced in between games, team manager Mariana stood alongside his secretary, Virginia Renee, anticipating the arrival of a supply vehicle. The field sat empty, and silence enveloped the stands. Suddenly, something caught his eye in the western sky. Initially, Mariana assumed it was merely the reflection from a jet. He shielded his eyes from the sun, tracking the two brilliant objects zipping in from the southwest. But these were no ordinary planes. Their intensity, smoothness, and perfectly circular forms set them apart. Mariana would later delineate them as two silvery disks, subtly rotating as they traveled side by side, resembling the lead and wing of an aerial formation. He dashed to his car, retrieved his 12mm motion picture camera from the glove compartment, and rushed back. By the time he returned, the objects had already traversed the city skyline. Advancing towards the east, he began filming, following their trajectory as they glided above the Anaconda smelter stacks. Through the viewfinder, he captured their bright white shimmer, contrasting against the vast blue expanse of the Montana sky. Mariana recorded for approximately 15 seconds before stopping to readjust his position. At that moment, the disks shifted slightly, catching the sun once more before accelerating away. Within seconds, they vanished from sight, disappearing over the horizon. This brief sequence, comprising about 20 frames of usable footage, emerged as one of the earliest and most scrutinized pieces of daylight UFO evidence in American history. Once Mariana developed the reel, he projected it on the office wall. Two luminous discs were visible entering the frame from the left, gliding gracefully, leaving a faint rotational blur in their wake. Ronig corroborated what she observed with her own eyes. They moved in unison like two coins flipping in the sunlight, devoid of wings or tails. The following day, he mentioned the sighting to friends at the local station, KFBB-TV. News spread rapidly. Within a week, representatives from Malmstrom Air Force Base, later known as Great Falls AFB, arrived, requesting the film for analysis. Mariana consented, stipulating its return. When weeks later the footage was finally returned, he discovered that a short segment of the film, specifically the initial frames capturing the discs at their closest proximity, had gone missing. Mariana later noted that he knew precisely what he had filmed. What came back to him was notably shorter. In ensuing months, NYAP, which was established years afterward but retroactively documenting events predating 1956, secured copies of Mariana's testimony and still frames of the film through civilian researchers. By the late 1950s, the case had secured its place within the organization's foundational archive of early photographic evidence. The film itself underwent evaluation by Louis Berliner and subsequently by Dr. Robert M. L. Baker, both photographic analysts affiliated with independent labs and those connected to the Air Force. Their comprehensive examination, conducted frame by frame, confirmed that the two objects maintained consistency in shape and movement, dismissing the possibilities of them being birds, reflections on the camera lens, or conventional aircraft. The discs sustained a consistent distance and mirrored angular velocity throughout the footage. In his analysis encapsulated by the National Investigations Committee on Aerial Phenomena, Baker remarked that the objects exhibited traits synonymous with self-illuminated or reflective structured entities. Evidence derived from the relative motion between frames indicated a stable trajectory, devoid of any tumbling effects. Notably, there were no observable wings, fuselage, or signs of propulsion. At this juncture, NICAP's focus shifted from conjecture to methodological precision. The organization meticulously documented every technical facet of the Great Falls film, including the camera model, a shutter speed of 1/50 seconds, the use of Kodak chrome film stock designed for daylight exposure, and a lens with a focal length of 20 millimeters. They aligned the sun's azimuth at 11:29 in the morning with the angle of the disc's reflections, ruling out any possibility of sunlight gleaming off distant aircraft, as the incident angles could not correspond to known flight paths over Great Falls on that particular morning. Mariana's reliability was further substantiated by his background. As a businessman and former Navy personnel, as well as a respected civic leader, he bore no incentives to exaggerate or fabricate his account. NICAP's subsequent reports consistently characterized him as articulate, accommodating, and reliable during extensive questioning. In an archived interview, Mariana recounted the scene with calm clarity, describing the objects as bright and metallic, rotating yet stable in their flight. He noted that he heard no sound. There were no contrails, only a seamless glide across the azure sky. The Great Falls film, which would later be referred to as the Mariana footage, evolved into a significant reference point within NICAP's photographic studies. In 1959, the organization released a comprehensive re-evaluation employing optical density metrics to explore the possibility that the discs were mere internal reflections. The findings, however, were negative. Both entities exhibited motion relative to a fixed horizon, maintaining independent parallax, thus confirming they were external to the camera. Notably, weather conditions recorded for that day indicated visibility at 35 miles, with winds from the southwest at 6 miles per hour and an unobstructed sky, conditions ideal for filming. The absence of clouds further eliminated any likelihood of reflective distortions. Reviewing Civil Aeronautics Administration flight records, only 2 aircraft were documented in the vicinity that morning: a Douglas DC-3 at 8,000 feet and a T-33 jet at 14,000 feet. Neither of these were in the required position or alignment of the recorded objects. In 1963, photographic analyst Dr. Roy Craig, later affiliated with the University of Colorado study, scrutinized a pristine version of the film and confidentially informed NICAP of his observations, stating that the two discernible objects were round, bright, and stable, with no discernible film artifacts. The apparent control of their joined motion suggested a structured origin. By this time, Mariana's brief footage had circulated widely among investigators and various television programs. Nonetheless, NICAP's methodical treatment of the material remained remarkably restrained. In its 1964 compendium, UFO Evidence, the case was encapsulated succinctly in 4 lines, noting the observation of 2 disc-like objects by a credible witness, the subsequent analysis conducted by photographic specialists confirming their externality, and that their appearance and movement were incompatible with those of birds or conventional aircraft, leaving the phenomenon unaccounted for. This measured approach lent the case a sense of durability. Unlike more sensational accounts, the Great Falls film stood resilient against decades of re-examination, each investigation reaffirming the same fundamental aspects: 2 brilliant circular forms exhibiting stable flight at a uniform speed, with no identifiable source. When NICAP researchers questioned Mariana again in 1966, he affirmed that his recollection remained vivid. It wasn't fear that gripped him at the time, he remarked. It was a profound sense of curiosity. They were under control, he recalled, emphasizing that this was the impression that lingered with him. Whatever they were, there appeared to be deliberate intent in their flight. Virginia's later reflections echoed this sentiment, noting how they moved as if bound by an invisible connection, asserting it felt too perfectly synchronized to be mere coincidence. Technical correspondence preserved by NICAP's Photographic Analysis Division included calculations by one analyst estimating the apparent separation between the 2 entities to be 2.4 degrees, approximately translating to 3,000 feet if the disks were situated at a distance of 40 miles, a calculation consistent with the parallax data sourced from background smelter stacks. This positioned their true diameters nearing 50 feet each. Such precision epitomized NICAP's investigative ethos, treating each numerical value in every witness statement as data to be recorded without presumption. The Great Falls film emerged as a standard against which subsequent cases were evaluated. When a daylight disk was reported in Utah in 1952 and another captured on film over New Mexico in 1957, NICAP researchers juxtaposed still images alongside Mariana's footage. The conspicuous similarity in circularity and reflective quality was undeniable. In 1972, amidst a historical review of photographic evidence, Richard Hall revisited the initial frames using advanced densitometry. His findings were succinct yet resonant. The original negative revealed no splices or alterations, with images aligning correspondingly to external light sources. The motion appeared consistent with structured metallic objects of unknown origins. By this time, the aged 16mm reel had been duplicated numerous times, each subsequent generation diminishing in sharpness, yet the core image persisted. 2 discs gliding in unison over a quaint American town. Today, the footage runs for less than 20 seconds, commencing with an expanse of blank blue sky. The discs then enter the frame, smooth and silver, traversing above the smokestacks before gradually fading from view. There is no theatrics, no background score, nor shaky camera work, simply steady motion captured by a man who possessed the foresight to tilt his lens skyward for those fleeting seconds on a brilliant Montana morning. For NICAP, the Great Falls incident embodied something unusually precious, objective, measurable, and inherently human. The case was archived not as definitive proof, but rather as thoroughly observed evidence, the kind of record capable of withstanding the test of time, unfettered by the burdens of belief. In his final note attached to the file, Hall expressed his candid observation that whatever the nature of these objects, they undeniably existed at the precise moment of exposure. The film makes no arguments, it merely presents. Now, after 75 years, that quiet image continues to flicker within archives and documentaries, representing the initial authentic daylight documentation amidst NIAP's extensive collection of structured luminous phenomena. Though the frame has aged, its motion remains fluid and graceful. Two mirrored discs glide eastward over Great Falls, Montana, eternally preserved in mere seconds of sunlight and celluloid, held in a tranquil silence. This narrative echoes from the White Sands Range incident, New Mexico, during 1957. One of the technicians murmured to his colleague, noting the unexpected return, indicating that it was no conventional aircraft. The radar room at White Sands, meticulously constructed for precision, typically vibrated with a soft static hum, embodying the steady tempo of instruments meticulously measuring distance, velocity, and time. Yet, this specific evening in 1957 shattered that norm. The glowing trace displayed on the scope was coolly steady, sharply defined, and traveling at remarkable speed, unnatural for anything the range had ever projected. Chief Warrant Officer Ben Davis, overseeing the shift, stood behind the control console, hands clasped behind his back. At 41, he was an experienced figure, having traversed the tortuous paths of both warfare and science, a radar specialist who transitioned from the U.S. Army Signal Corps in Europe to the Air Force's Missile Tracking Division. Those in his charge asserted that Davis possessed an uncanny ability to interpret an echo merely by observing the curve's shape. He had devoted decades of his life to scrutinizing phosphor displays, deciphering what many would dismiss as mere noise. On this particular night, however, what materialized on his screen was anything but noise. He instructed his operator to maintain the gain steady, and the return remained distinctly crisp. Entering the range from the north, the anomaly ascended, then paused abruptly positioned at the center of the scope. Frowning, Davis remarked to himself that this was robust and undeniably real metal. The atmosphere at White Sands during 1957 represented an ordered sphere. Every aircraft was meticulously documented, every missile accounted for, and every calibration logged to the precise second. There was nothing haphazard in that place. However, the unfolding events during the following minutes were decidedly peculiar. At a second radar station situated 30 meters away, the identical target was displayed at the same coordinates. Two separate systems, two distinct antennas, yet one solitary object. Both instruments affirmed the same conclusion: the contact was solid, swift, and under deliberate control. Davis interjected a call to range control, alerting them to the presence of an unknown high-altitude maneuver that was certainly not one of theirs. The return response was clipped and measured, instructing him to continue observation. For nearly a minute, the technicians remained transfixed as the blip held its position unwaveringly at an elevation of around 60,000 feet. Then, it abruptly veered eastward, accelerating beyond the scope's maximum measurable range. The trace stretched, distorted, and vanished, leaving the room enveloped in silence, save for the gentle whirring of cooling fans. When they reran the radar film, the movement was unequivocal, a clear track stitching across the grid, pausing momentarily, making a sudden 90-degree turn, and disappearing at a velocity that defied the limits of their apparatus. One of the operators speculated it might have been an echo or a malfunction. Davis shook his head, emphasizing that echoes do not come to a halt so definitively, nor do they execute sharp turns. He ordered the film to be labeled and securely stored for further analysis. Within a span of 24 hours, 2 men from Air Force intelligence arrived at the range, dressed in civilian attire and carrying unmarked cases. Their inquiries were brief, their demeanor polite, yet the essence of their mission was unmistakable. They collected the film, calibration charts, and even the handwritten logs without a stir of dissent. As one younger technician later recounted, their statement suggested it was merely an evaluation. However, once they departed, it became indelibly clear that the film would never resurface. Weeks later, a formal notification came through from Air Defense Command. It classified the event as a radar anomaly, likely a meteor reflection or atmospheric distortion. This explanation felt reminiscent, like a narrative excerpt pulled from a standard procedural template. To Davis, it came across as an affront. He had dedicated his career to discerning the nature of radar ghosts, and this instance was certainly not one of them. Meteors do not hover, he communicated to his team, and reflections do not create right angles. Daily operations at the range resumed. Rockets ascended and descended. Telemetry data filled the filing cabinets, and whispers about the incident circulated only in hushed tones. Nonetheless, the technicians involved did not allow the memory to fade. A few months later, amidst another missile test, 2 radar operators reported encountering a similar unknown that seemed to pace a launch. A faint luminous object was visually detected that evening, moving parallel to the trajectory of the rocket before suddenly darting skyward. Range Control dismissed it as mere coincidence, but Davis remained unconvinced. He stated, "We captured something real once. It is still present out there." By the time NICAP learned of the 1957 event, considerable time had passed. Many of the original documents had vanished, but 3 technicians, including Davis, submitted sworn testimonies to the organization. Each account recounted the same sequence: a solid radar return, abrupt changes in direction, a sustained hover, and an exit at speeds beyond contemporary technology. NICAP investigators meticulously cross-referenced launch schedules, affirming that no tests took place during that juncture. The skies were unobstructed, and the radar systems operated at full capacity. The conclusion emerged with clarity. The object was real, physical, and detached from any military operations. For the analysts stationed in Washington, this case symbolized a rare convergence of elements: trained observers, corroborated radar stations, and an official suppression of primary evidence. The entry materialized in the 1964 UFO evidence under radar visual correlation, White Sands Missile Range. 1957. It was succinct yet significant, serving as a poignant reminder that the most critical data points often remain cloaked in silence under governmental discretion. Ben Davis, having retired from his distinguished career 2 years later, found solace in Colorado alongside his wife and their 2 sons. Though he seldom recounted his experiences at White Sands, a letter to a former associate contained a haunting phrase: "The night the radar discerned something that the rest of the world was unprepared for." His correspondence concluded with a solitary line: "I don't know what it was, but it was acutely aware of our existence." Those who served under his command recalled him as both exacting and equitable, a technician who sought irrefutable evidence rather than mere faith. One of them recounted to NICAP researchers that if he affirmed something's authenticity, then it was indeed genuine. Yet, as Air Force records were meticulously reviewed years later under the declassification mandate, the segment detailing that fateful night vanished inexplicably. The radar film was misfiled, and calibration sheets, it was noted, had suffered destruction in storage. No record of the data endured in the aftermath, but the witnesses remained, their memories persisting vividly over the decades. One individual recounted how he could still envision the trace playing across his mind: the vivid sweep cutting through the dark grid, the extraordinary halt, the sudden vertical climb toward the east. "It was immaculate," he remarked. "Too immaculate to be mere noise. It felt as though something out there was demonstrating its capabilities." For NYAP, the incident at White Sands represented quiet testimony that the phenomenon transcended mere visual sightings. It was quantifiable, documented, and replicable in controlled settings. It embodied a scientific enigma in its truest form, observed by specialists, logged by devices, and concealed beneath bureaucratic protocols. Ultimately, what persists from that everlasting night is the collective recollection of a few men. Radar operators in the arid desert, fixated on instruments revealing a truth that few wish to acknowledge. Somewhere amidst the vast empty territories of New Mexico, a solitary blip coursed across the screen with intent, halted, and then vanished, leaving behind only silence, inquiries, and the legacy of Chief Warrant Officer Ben Davis, who had seen enough to understand it was anything but an error. Misawa Air Force Base metallic disc near AT-6 and F-84, 1952, Japan. The Sea of Japan gleamed through a delicate veil of morning mist as the flight line at Misawa Air Base stirred to life. Mechanics moved purposefully among the park of aircraft, their tools emitting a gentle clinking sound in the tranquil air. In the distance, a North American AT-6 trainer began to taxi. Its sunlit yellow fuselage reflected the first rays of late spring's warmth. The pilot, First Lieutenant William Schaefer, had accumulated numerous flight hours traversing the skies over Aomori Prefecture, an area marked by a tapestry of coastline, verdant pine forests, and faraway mountains. He was preparing for a brief navigation exercise to the north of the base, a commonplace flight in every regard. At several thousand feet above him, 2 Republic F-84 Thunderjets soared, engaged in formation practice under the direction of radio control. Their vapor trails unfurled as pale streaks against a soft blue-gray canvas punctuated by scattered cumulus clouds. At Misawa, it was a day marked by stillness, no alerts triggered, no weather balloons to monitor, and no incoming traffic except the standard supply flights from Yokota. Schaefer's AT-6 ascended smoothly through 8,000 feet, the horizon radiating brightness, the sea shimmering like polished steel. He adjusted his course to the west and checked his instruments. Then, as he leveled off, an unexpected glimmer caught his attention from the left wing. It was not a mere reflection from his canopy or a contrail high above. It was a metallic flash, small yet pointed, proceeding on a parallel trajectory. Initially, he surmised it might be a far-off aircraft. As he slightly banked toward it, he anticipated identifying wings or fuselage markings. Instead, the object manifested itself as a thin, round disc, flat, reflective, and devoid of features. Matching his altitude and speed almost precisely, it lingered just 200 yards off his wingtip. After several seconds, it tilted, unveiling a dull gray underbelly, and began to rotate slowly, akin to a spinning coin. I could discern no protrusions, he later documented in his report. No tail, no cockpit, no exhaust. It was metallic, gleaming brightly from above while dull on the underside, spinning around its own axis. Schaefer radioed the tower to report a possible unidentified aerial object. The controller acknowledged his transmission, instructing him to maintain visual contact whenever feasible. As he steadied his plane, the object executed a sudden, smooth ascent. It did not accelerate sharply, nor did it curve. It merely ascended vertically, defying the known physics of conventional aircraft. In mere seconds, it passed through a thin layer of clouds, re-emerging higher, where sunlight glinted off it again in a bright flash. Concurrently, the F-84 formation, flying at an altitude of approximately 12,000 feet, reported observing a luminous circular reflection below. The lead pilot, Captain Harold Owens, reported that they had visual contact with something metallic to the left of the AT-6, ascending swiftly. Both Thunderjet pilots watched as the disk arced above their altitude and vanished into the upper haze. Their flight briefing would later document that the object had climbed rapidly before disappearing without a trail. Schaefer maintained his heading, climbing slightly to 10,000 feet in hopes of reacquiring the target. The sky lay emptily around him. He circled twice, scanning the clouds, then turned back toward Misawa. The entire incident spanned just under 2 minutes. Upon returning to the base operations building, Schaefer was greeted by the duty intelligence officer, alongside a weather liaison from the Japanese Meteorological Bureau. They meticulously examined the radar logs, revealing that for around 40 seconds, one of the CPS-5 radar stations had registered an intermittent echo to the northwest of the airfield, correlating with Schaefer's location. The track appeared momentarily before vanishing once again, too brief to ascertain speed or altitude. No additional traffic occupied the sector. The Japanese weather representative confirmed that no balloon launches had been scheduled or initiated from Aomori or Akita stations that morning. Data on upper atmospheric conditions illustrated winds aloft moving eastward, positioning Schaefer's sighting directly to the west of the prevailing flow. A balloon could not have achieved his trajectory or velocity. In his official report, Schaefer articulated the object's steadiness and movement. He noted that it was under control, neither drifting nor tumbling, and it maintained level flight alongside him before ascending vertically. Testimonies from the F-84 pilots mirrored his depiction. One pilot remarked that the sunlight glinting off the object's surface was steady, lacking the flickering often associated with rotating wings. That afternoon, Base Intelligence compiled a joint report and transmitted it through the channels of the Far East Air Force to the 604th Air Intelligence Service Squadron in Tokyo. Subsequently, it found its way to the Air Technical Intelligence Center at Wright-Patterson Air Force Base, where analysts involved in Project Blue Book documented it as an unidentified aerial object reported by multiple aircraft near Misawa Air Base, Japan, in May 1952. The analysts scrutinized the case alongside other sightings from the Pacific that year, which included reports from Fukuoka, Kaseyabo, and the Korean Peninsula, each detailing bright disc-shaped objects observed under clear skies. The Misawa incident distinguished itself because it encompassed simultaneous observations from 3 aircraft of varying types, alongside partial radar contact. The geometry of the occurrence left scant possibility for misidentification. 3 separate perspectives described the same small metallic disk traversing in a steady direction before it vanished vertically. Meteorological analysis dismissed mirages as temperature and humidity profiles indicated no inversion layer capable of producing reflections. Astronomical evaluations ruled out Venus, which remained below the horizon at that hour, and there were no recorded meteor events for the area. By June, the Air Technical Intelligence Center had prepared its summary. The object was characterized as metallic, circular, and exhibited maneuverability inconsistent with that of wind-borne debris or conventional aircraft. The brief radar contact suggested a tangible presence. The classification assigned was unidentified. In the subsequent weeks, whispers circulated quietly across the base. Pilots in the Officers' Club exchanged stories about the silvery disk glinting over the bay. Some dismissed it with laughter, while others inspected their gun cameras prior to each flight. Schaefer personally retained a copy of his report for years, in a correspondence with a fellow pilot decades later. He conveyed simply that it was real enough to pursue and swift enough to evade. The F-84 crews who spotted the disk from above were equally convinced. One remarked to an interviewer that it moved unlike any balloon or aircraft they had encountered, recalling how they watched as it turned into the sun and shot straight upwards. His tone remained devoid of drama, just matter of fact, akin to an engineer discussing data. Project Blue Book's case file retained its brevity yet consistency. 1 AT-6, 2 F-84s, a solitary radar blip, and an occurrence brief enough to be measured in mere seconds. Nonetheless, these few particulars elevated it among the most compelling metallic object reports from the entire Far East Command during the early 1950s. The incident materialized during a time of heightened military readiness. The Korean War had concluded just months prior, and United States bases throughout Japan remained vigilant for any unidentified aircraft breaching restricted airspace. Analysts at FEAF headquarters contemplated whether the disk might have belonged to a Soviet reconnaissance balloon or experimental vehicle, but intelligence records from that era disclosed no evidence of enemy overflights, nor did any later declassified documents match the observed description. When the Air Force revisited the file in 1955, it arrived at the same conclusion. The entry was succinct, indicating that no known aircraft or natural phenomena could account for the observation. The object was metallic, circular, and appeared to be under intelligent control. In the following years, the incident nearly faded from official records, overshadowed by larger radar visual occurrences in Europe and the United States. Yet among pilots who served in Japan during that era, the Misawa disk remained a small legend, an encounter that allowed no room for speculation, presenting simply a clear, illuminated sighting of something that transcended the monotony of flight. Its lingering essence stemmed from its simplicity. One disk, perfectly circular, emerging in daylight before trained air crews, traced by radar for mere seconds, yet remembered with precision over decades. It evaded complex maneuvers or peculiar lights. It merely materialized, mirrored an aircraft's course, rotated once, and descended out of reach. Even now, aviation historians reference the case as a paragon of early Cold War reporting discipline. Concise, factual, and devoid of emotional embellishment. There were no extravagant claims, no discussions of extraterrestrial visitors or weapon systems, just trained observers detailing an object whose behavior exceeded the technological boundaries of its era. The concluding page of the Blue Book file contains a solitary typewritten paragraph, visual observation by qualified military pilots corroborated by radar, description of a metallic disc approximately 20 to 30 feet in diameter with a duration of 2 minutes. The documentation ends there, accompanied by the small stamp that sealed numerous analogous mysteries. Case completed. The sky over northern Japan that morning returned to its routine tranquility. The AT-6 landed without incident, the F-84s persisted in their exercises, and the radar scope reverted to blankness. However, for the few men who had ascertained that disk rising into the azure, it remained an indelible image they could never fully erase. A simple shape shimmering in sunlight, ascending straight into the unknown. As always, I appreciate your presence with Dreams of Disclosure. Please like this video, subscribe to the channel, and join us each day as we uncover more rare accounts of alien encounters and UFO sightings.